Hello and welcome to the second day of MIDI conference. We have exciting things going on planned for today. We'll have two sessions for paper presentations. We'll have presentations from the Łukasiewicz Research Network on urban mobility. We will announce the winners of Best Paper Award, and of course we have a keynote from Professor Pedrich planned for the end of the conference. And we will start today with the first session on machine intelligence. The chair of this session will be Dr. Rana Hamad Raza from National University of Science and Technology from Pakistan. Dr. Raza, the floor is yours.
Thanks, Dr. Cesare Biel, for introducing myself. It's nice to see you all here. I would like to start the machine intelligence session with a quote of Ginny Rometty regarding artificial intelligence. Some people call this artificial intelligence, but the reality is that this technology will enhance us. So instead of artificial intelligence, I think we will augment our intelligence. So having said that, dear presenters and participants, just a quick reminder that we have around 1 hour and 15 minutes for this session. Since we will be following asynchronous mode, therefore all presentations for the sessions are pre-recorded and the video presentations will be played accordingly. Before the video presentation starts, the presenting authors are requested to be available. After the question and answer session, please provide us quick introduction about yourself, which should include your name, institution, the country, and a little bit of brief background where you belong. And after each video presentation, we will have a live question and answer session accordingly. The chat will be opened, and I encourage all the conference audience to please ask questions and interact and share the opinions on the chat. A dedicated channel on the website Slido is also available. I will keep a track of the time to remain within the boundaries and the schedule of the session, and there will be breakout rooms for the participants for any kind of extended questions and interact with the presenters if they want to, and with other participants as well. And one last thing, that presenters have to click the join audio button before they can be unmuted. So having said that, this session will have around 4 presentations. The first presentation is regarding determining geolocation of tweets using cognitive intelligence. It is being presented by Aishwarya Ashish. And please note that this presentation is without the voice of the presenter. Only music and text is there. So if I could request my technical host Bartos to please play the first video for the presentation. Thanks for the presentation. Aish, if you can actually introduce yourself with a little bit of introduction, where you are, where you belong to, and a little bit about your background. So we'll be happy, and then we'll ask few of questions from you.
Yeah, surely. So like currently I'm in the US and like after, I've been involved with research and like after doing my bachelor's in India, I came to US for my master's and after completing the like science master's degree, I'm just working with Adobe and currently like actively researching on AI and machine learning techniques on how we can solve like daily life problems and like time series analysis and forecasting is one of the major reasons of my research. And yeah, that's it for me, like a short introduction.
That's great, Aish. And I would like to offer and open the house for questions that you will like to ask from all the participants. They can write your question in the chat box, which you will like to Aish to answer with respect to his paper, please. So I will wait for a couple of seconds till the time somebody writes this in this chat.
Yeah, surely.
Seems like there are no questions coming from the audience from now. For now, so to break the ice, actually, I would like to ask the question for a quick um, uh, uh, to uh, to actually vibrate the participants as well as, and I'm also going to paste it in the chat box for your quick reference and the all the participants as well. So if you can see, I would like to ask that how many k most similar authors like for a given data set that you have will affect the model in terms of their data dimensionality. And coming with the continuation of the
Yeah,
second
so
question. Yeah, please.
yeah, surely. So like this research actually presents a multi-level, multi-dimensional like process that reasons jointly about like latent topics and geographical regions. So like as we all know, like high-level topics such as sports or entertainment or political views are like discussed differently in each geographic region, and they reveal very like topic specific regional characteristics and also like preferences of the people and what all biases they have. So the data sets we have used, like it's taken from Twitter like via its API. So there are two major geographical regions that we have distributed the whole research on. Like the first one is based off in US, and the second one is based off in Australian data set. And like we are just trying to predict the location of the user by knowing what content or what text message he wrote about in a particular tweet message. And so the collection of text actually contains like data from like around 9K different geolocated users, and that's for the US dataset. And the key variables are like the user ID, document position, word count in the forms of triplets, like the latitude and longitude, like coordinates of each user, user information, a vocab section which contains the vocabulary file and also the doc count. So like it was observed that people on the east side of US like use similar words. The similarity score while on the was on the lower side. Like one can attribute this to presence of like high noise in the data, maybe. And some tweets had like space in between the words, so while some didn't. So if the data was clean enough, the similarity measure would have been on a relatively higher scale. Like not all algorithms are applicable to every data set. So it was just a key observation that the TF-IDF failed because of ill punctuated words, I can say that. And like similarly for a general context in Australian data set, like to measure the effectiveness of different approaches, like the execution time, accuracy, macro averaging precision, and I guess like the recall and F score were used since the classes were distributed equally. And it also included the results distribution, cities with most correct and incorrect information, and so various combination of feature engineering hyperparameters were experimented. And I think like the table 2 and 3 of my paper like summarizes only a part of result, and the best classifier was dependent on first ACC and then time.
Okay, I think you answered my second question as well, which is there. So we have a couple of questions coming from Mr. Grisgors. Pardon me if I have not pronounced your name properly, dear. So the question is, does it work with texts that are not taken from Twitter? And I mean, what he means to ask is what extent it is Twitter specific, because Twitter
Yeah,
forces
so
forces a certain way of communication.
yeah, surely that's a nice question, and I like to answer it like by stating that we have compiled like a bunch of text from a same user. Like it contains maybe 5 or 6 tweets of a similar user. So this thing works generalized based on how many users we have in the subset. And even if you just maybe take a sample of a book written by different users and just give it as an input to the algorithm, I think it will work. Like there's some amount of experimentation needs to be done in this aspect, as we have mentioned in the future research work. But yeah, it's not specifically based on Twitter. It's based on a single author writing a bunch of text, and that can be taken from anywhere, basically.
Thanks, Sash. Thanks for your time in presenting here.
Yeah, no
We move
worries.
on, we will move on to the next paper, which is the prediction of location using unsupervised learning method to open a restaurant branch. It is being presented by Mr. Hariharan, and the paper co-authors are Resh Pichai and Dilshad Fatima. Uh, Bartos, my technical host, if you can please play the first the video of the presentation. Following that, I'd like the co-author to please introduce yourself, and then we'll follow the live questions.
The topic is prediction of location using unsupervised learning method to open a restaurant branch. Myself Hariharan, I am presenting today an agenda. This is the agenda we are going to be discussed today. An objective to predict the location of any business venue using the machine learning algorithm. This paper particularly focus on opening the restaurant branch in Bangalore using K-means. And restaurant is most profitable business in India. When we coming to the restaurant, location will decide the success of the business. Location should have a easy accessibility by the customer and getting doorstep service of raw materials. Location has significant effect on the restaurant market share and profit. Individual customer service is the important factors in restaurant. When we selecting the restaurant location, we should think from the customer side and also the management perspective. Neighborhood of the restaurant has its own advantage and disadvantages based on the type of the restaurant. And some of the major factors leads to success or failures of the restaurant, that is what is the need of the hotel in the particular place, and the accessibility of the from the customer and the vendors, and living style of the people, and traffic pattern, and existence of the additional business including the other restaurants. And we have done a 5 papers literature survey, and I just given over here. And multi-criteria selection for the restaurant location in Taipei, they are used the Vicar ranking algorithm and a data mining framework based on rough set theory. They improve the location selection the decision. They have used the rough set theory and a fuzzy multi-criteria decision model for international tourist hotel location selection. In that they have used the multi-criteria decision making model, where to place your next restaurant, optimal restaurant placement via the leverage user generated reviews. The leveraging they are getting the review from the users, and based on the investigation they are taking the decision. And bike sharing and placement leveraging heterogeneous urban open data, they are using the semi supervised feature learning method to utilize the optimum sharing of that bike. And methodology, this is the methodology what we are proposing: the data collection, data preparation, data analysis, data interpretation. And in data collection, we are scrapping the web pages with a pin code and a neighborhood listed, obtaining the geographical coordinates using the Foursquare API for collecting the venue list. We are using the beautiful soup packages, and 294 neighborhoods we found, and 99 unique postal codes we have found, and 2 invalid postal codes are removed. And we use the Foursquare API to get the most common venues of the given neighborhood, and using the geocoder Python function, we can able to get the coordinates of the each neighborhood. And while data preparation, the removal of neighborhoods row without the postal codes value is the first pre-processing task performed on the raw data, and applying the one hot encoding on venue category to bring the linearity in the features. And finally, we are grouping the neighbor which sharing the same pin code in a single column to avoid the repetition of pin codes. And data analysis, we are using the latitude and longitude venues to get the visualize as the figure, and utilizing a Foursquare API to explore the neighborhood venue and segment them. And we define the limit of number of venues is the 100, and we are giving the radius will be 750 meters for the each neighborhood from the given latitude and the longitude. And this is the data analysis we have done. And k-means clustering, the k-means clustering is one of the simplest unsupervised learning algorithm that solve the well-known clustering problem. The procedure follows the simple and easy way to classify the given dataset through the certain number of cluster. The main idea is to define k center, one of the each cluster. These centers should be placed in a cunning way because of different location cause different result. So the better choice is to place them as much as possible far away from the each. The next step is to take each point belong to the given data set and associate to the nearest center. When no point is pending, the first step is complete and an early group age is done. At the point, we need to recalculate the k new centroid as the barycenter of the clusters resulting from the previous step. After we have this k new centroid, a new binding has been done between the same data set points and the nearest new cluster. A loop has been generated. A result of this loop, we may notice that k centers change their location step by step until no changes are done. This is the mathematical formula for the k-means clustering. And whatever we have discussed as a theory, that we have given the algorithmic form in the k-means cluster. This is the sample. The n value is equal to 60 and 3 for the 3 clusters, how the k-means has worked. And this is the iteration, step-by-step iteration, how the k-means has worked. And see the difference between iteration 0 and iteration 5, how the k-means has worked. And this is the sample data frame head from the analysis. Then the interpretation. So the data interpretation, we have some pin code which is having the more than 50 venues with 750 meter radius, and we have another some of the pin code which have the 10 venues and we within the given coordinate. Okay, in the summary, 195 unique data was returned by the Foursquare, and we created the table which show the top 10 venue category for the neighborhood in table. We have some common venue categories in neighbor. This is the major reason to unsupervised learning k-means algorithm clustering the neighborhoods. And this is the merged table of postal codes and the venue. This is the visualizing the cluster, the different clusters visualization, and top 10 venue category for each neighborhood, and merged table with the cluster label for each neighborhood. You can see the fifth column is our label, cluster label. And elbow method, here we can tell that the elbow is giving the 6 optimal value. Optimal clusters will be that 6. From the 6 only our elbow is getting the crossed. And the algorithm, so this algorithm is nothing but whatever we have discussed as of now, we have given us the algorithmic way. And we just get the postal code from the beautiful soap packages, and we are applying the one hot encoding, and we are just keeping our radius will be less than 750 meters, and from that inside that we are just finding how many locations are found, how many unique things are found, and we are repeating the same, and just we are keeping that we are getting the 6 clusters from the clusters. We can found which one is the most frequently visited one. And the result, the k-means algorithm is one of the most common cluster method of unsupervised learning. The k-means is used to cluster the neighborhoods into the 6 cluster, because we analyze the k-means with the elbow method is ensure the 6 degree for the optimal value k of the k-means, and each cluster can estimate the number of first most common venue. As a result, we can tell that cluster 0 having the bus station, cluster 1 having the pharmacy, cluster 2 having the Indian restaurant, 3 having the astrology, and 4 having the mixture of venues, and 5 is having the athletic and sports. So from this we can tell the cluster 2 of the neighborhoods with the Indian restaurant as most frequently visited venue. From the conclusion, we can conclude this paper proposed and study the performance of unsupervised learning method k-means clustering to cluster the area to find the best location to start the new branch of restaurant in Bangalore. And we have using the elbow method to find the optimum number of cluster, and cluster 2 has found out the best location to start the venue restaurant. People are turned to the biggest city to start their business or work. For this reason, so we are come out with their access to platform where such information is provided. The proposed method is the computationally faster and is efficient and easy interrupt, not only for food joints but also we can use for the city managers, traffic controllers, and other business also we can use the same kind of method. And this is the reference what I have referred for my paper. Thank you.
Thanks, Hariharan. Thank you for updating us. Just a quick introduction we'll like so that everybody should know about you. And then we'll follow with the question and answer session.
Sir, myself Hariharan. I'm working as an assistant professor in Chennai, India, Tech University, and I'm doing my research in Electrocardiography in the area of image processing and machine
Okay. Okay. Thanks for the introduction, Hari. We'd like to have some questions from the audience if there are any. I hope the participants will be sending some questions. I'm just trying to monitor my chat window, which is if we get some questions, otherwise I'll add some from my side. Yeah. So we'll wait for another 5-10 seconds and let's see. I think by the time we get some questions from the audience, I will like to ask one question here, that how is the model comparable to other related work using a different or a wider range of features? If you can.
Sir, actually, this paper we are not compared with other models, sir, because the thing is, whatever paper we have surveyed, the problem is they have taken different features, and more than that, the application will be totally different. So actually, we tried to compare with other works, but not able to do because their work is totally different, and their application, everything will be totally different.
Okay, but can you explain a reason why placing or how placing centers far away from each other is a better choice in this case?
Sorry, sir.
How placing centers at a far away distance is a better choice in your approach? You have suggested to place centers at a farther distance, and how it is a better choice.
Sir, actually, we are just calculating using the how the performance is going, how people are accessing. So we are just seeing how people are accessing, because previous people, maximum people are are opening the new restaurant, that accessible based on that only we are giving the details. Even in presentation itself, there will be the advantage and disadvantages. If more number of people is coming to the same place, sometimes it will be like the same place. We are going opening one more restaurant. Sometimes it will be get good result, and sometimes this is the main drawback also, sir. But the maximum situations, if the population is more, because if you are seeing the Bangalore and all, the city, like a city like a Bangalore, then there and all we can expect because daily we are getting more population. People are migrating to IT companies. So these kind of places, definitely it will be wherever people are coming, uh, whoever coming to our location, definitely this business will be profitable for this kind of metropolitan cities. But we can't expect the same for normal outside metropolitan cities or normal cities or villages.
Obviously, with that, the traffic will also be one of the major feature set which
Yes,
will
sir.
be
Yes, sir. Yes, sir. Traffic also one of that's even presentation itself I used to tell how we have to give that proper vehicle parking, everything when we are providing the set. That will be one of the advantages when we are opening the restaurants.
There is one question coming from Mr. Amar. Can you please specify how the algorithm searches for the competition restaurants, for the competing restaurants nearby?
That's only, sir. We are just taking the area pin code with what is that available. For example, if I am taking the area pin code 5006. So in 506, what are the things available, registered available? For example, this number of restaurants available, this number of salon available, this number of school available, college available. So we are taking this stuff. So automatically, when we are feeding into that our system, it used to cluster like a, so this data will belongs to one particular category, like it used to cluster, sir.
Okay. Just a quick question, one more, that will the model still reach to a good prediction if the number of venues are not limited to a particular value?
Number of models?
Means will the model still reach to a good prediction if the number of venues are not limited to a particular value which you are there, like that?
That we are working on that, sir. Actually, but as of now, we are giving some limited values only because we are scrapping from the online internet only, sir. This data actually we are having some limitation. So when we are training our data itself, we are just doing the practice and we are just predicting. As of now, we are working on this. After your question, we will try to work on without that not limited data.
Okay. Thanks, Ariaran, for your presentation and the question and answer session, for explaining your work more to the audience. We'd like to thank you, and we'll move over to the third presentation of this session. I hope we are on time with the schedule as well. So the third presentation is a framework to support creation of artificial intelligence applications for low power wireless sensor network nodes. It is being presented by Mr. Christophe Petrovsky, and the paper co-author is Mr. Christophe Petrovsky. If I could request my technical host Bartos to please play the presentation.
Hello everyone. Before we begin, let me introduce myself briefly. My name is Christophe Petrovsky and I work at IHP. This is Innovation for High Performance in Microelectronic Institute in Frankfurt Oder. I am a PhD student and I would like to present you the concept of my PhD thesis. The topic is related to the scientific problems that need to be solved in order to be able to develop a framework to accelerate and simplify creating artificial intelligence application for low-power embedded devices. I will begin with the general concept behind this framework, and then I will give you some more specific information about the scientific issues to be solved. I will conclude my talk with some examples of use cases that help better illustrate the concept and the goal to be achieved. AI-based solutions are used nowadays in many application scenarios. They also approach the embedded devices area. Please imagine a situation where customer comes to an AI expert and asks for a special embedded system. This system must carry out tasks related to artificial intelligence, and it must be performed by low-power microcontroller. Of course, it is possible to do it from scratch, but it would be more comfortable to have a tool that will do it for us automatically or semi-automatically. For this reason, the idea to design a tool that will improve and automate this process was born. We have called this tool the Low-Power AI Application Framework. The picture shows the application development process. The customer provides all necessary details to the integrator. With the help of the integrator, the customer has to prepare a structured problem description, define the input data, and specify the expected results. It is also to be defined if the AI structure can be trained offline or if it should collect the knowledge also on runtime. The target device shall also be defined at this step because this defines the available resources. The very details will differ from application to application according to the presented problem, but following this procedure is required, and the problem description content must cover all the necessary aspects. The second step is performed by the integrator using the framework. He is responsible for carrying out the AI structure configuration process. This process will be supported by the expert system. The structured problem description will be provided into the expert system, and on this basis, a structure for the model will be defined. It means the kind of the underlying AI, like a simple neural network, LSTM, decision trees, fuzzy logic, or others. Further, during the configuration process, the structure is dimensioned according to the description, meaning for instance that the number of inputs and outputs and the number of layers are defined. In addition, the framework will adapt a set of helpful information about where and how to save energy in the target application. In the last action of the step, the structure may be trained if applicable. The next step is the code generation process. It is responsible for creating all necessary files that have to be uploaded to the target hardware platform. The result of this step will be a package for the main application, the necessary libraries, and the pre-prepared model of artificial intelligence. After uploading these files to the microcontroller, the system is ready for use. In order to better illustrate what this tool can be used for, we choose several cases of use. The first use case is the electricity consumption forecast. Customer needs a system that will estimate local electricity consumption for the next 24 hours. The system must operate on a microcontroller located in a substation. For this purpose, customer has prepared a set of historical data about the electricity consumption, temperature, and humidity in a given period. An AI model will be generated on the basis of this data. In addition, the customer must specify the measurement intervals. This is related to the energy efficiency of the system. The prediction will be generated based on the measurements received from an electricity meter that is located in the substation. The second use case is automatic detection of heart diseases using electrocardiography and artificial intelligence. The client asks to design a system responsible for automatic detection of heart diseases. He prepared historical ECG measurements with marked patterns and heart diseases related to them. This system will detect diseases based on measurements from electrodes that are connected to the patient's limbs. And that brings us to the end. I would like to thank you for your time and attention today.
Thanks, Christophe. Turhan, if you can please switch on your camera and briefly introduce yourself, that would be great, dear.
Hello.
Hi.
Hi,
Christophe Petrovsky, thanks for coming and present. Both of you are here, so that is great.
Yes, I've seen that I've also been asked to switch on my video, so I did.
That's great. That's great.
Okay,
That's
so we are both available for questions.
Sure.
So, hello everyone. I have introduced myself at the beginning of the presentation, but I can do it again. My name is Christophe Turhan, and I complete my master degrees in computer science in Poland, in Zielona Góra. Now I work at IHP. As I said, this is Innovation for High Performance Institute in Germany. My work is mainly related to low power wireless sensor networks, but for some time now, it is also artificial intelligence. Okay, thank you.
You can introduce yourself as well, Petrovsky. That would be great, dear.
Okay, so my name is Christophe Petrovsky. I am, well, several years ago, I also studied at the University of Zielona Góra and am now working since 2004 at IHP. And I am leading several scientific projects there. And Christophe is one of the members of my team. And well,
that's great. That's great. Means we are nice to have you both around here. We'll wait for like 5-10 seconds if we have some questions coming up from the audience in the chat box. I don't see any still. If there are none, then we'll. Yeah, there's one from Mr. Amit Agarwal. He's asking that what sort of AI models did you use on the wireless sensor nodes, and did you try to use deep learning models as well?
Actually, this project is in its initial phase, and we currently exploring what similar solutions are already available. So we didn't check any models yet.
Okay.
Sorry for noise. So if I can add something,
Yeah, sure.
We were focusing right now on neural networks, and as you can imagine, wireless sensor networks don't have enough power to run deep learning algorithms. So it was rather focusing on, for example, investigating how the problem can be modeled by a neural network and train the network offline, and then use the trained model on the low power devices to do the recognition of patterns and things like that. So that was the case for more powerful nodes like the embedded PC level, like Raspberry Pi or BeagleBone. We are already thinking about more complex problems. So training online is also possible then, but we have to consider the costs, because the training phase is the most expensive one, and in most of the cases. So I think it's all the matter of keeping the balance between the costs and the performance.
Thanks for the detailed explanation that we might not be using deep learning right now, but we are on that path. So that's a nice area and a wonderful work. I just have a few two questions. I think there is none other coming from the audience. So based on even basic AI, so how is the training being optimized, and what are the learning parameters? And to just complete my question, that what is the validation and the evaluation criteria for the AI framework? How does the model reach on a conclusion? If you can just summarize in like in 1-2 minutes, that will be great.
Christophe, can you explain?
Okay, so as Christophe said before, we are now actually, he is now investigating the area. So
Okay.
the most important tasks of this framework are first to do the proper mapping between the problem and the structure. So the artificial intelligence structure to be used. And the second point is the preparation of the data, because
Okay.
even if the customer comes to the engineer or to the integrator and says, look, I have, for example, brainwave recordings, they need to be prepared. They need to be normalized and things like that. And also the data that is later used to be the input of the final system also needs to be prepared. And these are the most important issues that need to be automatized. So if we get this this mapping between problem class and the proper structure that solve this problem, then in an automatic way, and then the evaluation of the framework would be how efficient it was. So you can have, for example, a very complex neural network models with thousands or millions of neurons, and actually you don't need it. You can have it oversized, and actually you need like 100 of neurons to solve the issue. And this is the this will be the evaluation of the framework, how good and how energy efficient the final AI system will be.
Thank you for the detailed answer. Mike, I got the answer to the query. It's more focused towards the framework and towards the hardware right now. So, and then it comes towards the soft part of it. So that's where we are progressing to in your approach. So that is great, dear. Thanks, Christophe Turkhan and Christophe Petrovsky, for your time and presenting here and explaining all the queries to us. We'd like to move forward to our fourth and the last presentation of this session 2 of machine intelligence. Um, this is regarding effectiveness of state-of-the-art super resolution algorithm in the surveillance environment, and it is being presented by Mr. Muhammad Ali Farooq. This paper are co-authored by Amar Ali Khan, Ansar Ahmad, and myself. If I could request my technical host Bartos and Daniel, if you can please play the video presentation for us, that would be great, please.
Comparative analysis of state-of-the-art super-resolution algorithms in surveillance environment. Super-resolution is an image enhancement technique which converts a lower resolution image into a higher resolution image. Super-resolution finds applications in satellite imagery, biometric verification, and surveillance systems. In this work, we have inspected the effectiveness of 4 conventional and 3 deep learning-based SR algorithms with the objective of seeking the finest method that executes well in a particular surveillance environment with limited training data options. Surveillance environment is an uncontrolled environment where the subjects and objects are moving randomly and constitute a very small portion of the image. Surveillance systems require zooming of a specific area of interest in the image where high resolution becomes essential. In the visible example, super resolution aids in identifying the number plate of the car which wasn't clear through conventional zooming. In both the visible examples, the person can be better identified through super resolution. In our work, we have chosen 7 single-input super resolution algorithms. The selected algorithms are contemporary and state-of-the-art in the last few years. They are well cited and published in top-tier platforms. Out of the 7, 4 of them are conventional and contemporary SR algorithms and 3 are based on deep learning. Among the deep learning-based methods, 2 are based on a convolutional neural network and the remaining 1 leverages a generative adversarial network. In super resolution via sparse representation, the algorithm proposes that image patches can be very much regarded as a sparse linear combination of elements, which in turn reduces the computational complexity. Sparse matrix indicates a column matrix with more zero rows than non-zero rows. In super resolution via sparse regression, super resolution is achieved using sparse regression theorem. In this theorem, a map is found from a dictionary of low-resolution patches and high-resolution patches using kernel ridge regression. In super resolution via self-transformed exemplars, rather than using external dictionaries, the paper uses internal dictionary generated from the input image itself to produce high-resolution image from the given low-resolution image. The algorithm will search examples in the downscaled version of the input image by removing its mean. The accuracy of the internal dictionary is enhanced due to the algorithm's allowance to produce geometric patches. Another self-similarity-based algorithm is super resolution via patch redundancy. The algorithm will consider the input low-resolution patch and find its corresponding neighbor patch in the downsampled version of the image. One additional step is that it also searches for patches within the same scale of the input low-resolution image. If the difference between the input patch and the neighbor patch is at a sub-pixel level, then high-resolution patch is achieved. Hence, this algorithm combines the properties of single-image super resolution and multi-image super resolution. In super resolution via convolutional neural network, the algorithm produces a high-resolution result through deep learning. The structure consists of 3 layers, which are the feature extraction layer, the mapping layer, and the reconstruction layer. In enhanced deep residual networks for single-image super resolution, a residual learning-based deep super resolution network is proposed that enhances the performance of previously proposed methods by model optimization that involves removal of unnecessary modules in convolutional residual networks. The authors develop a single-scale super resolution model that achieves state-of-the-art performance. Enhanced super resolution generative adversarial networks proposes an improved generative adversarial network-based super resolution model, building on the older SR-GAN, to achieve better perceptual quality. The authors have proposed an architecture consisting of several residual and residual dense blocks with the bottleneck layers removed to improve performance. They also introduce the use of a relativistic GAN, which can learn to judge whether one image is more realistic than another image. For our work, we have gathered local datasets as well as publicly available datasets. For local datasets, we have taken images of different subjects in university campus environment using CCTV camera stream. For public datasets, we used a subset of 220 images from PETS, Caviar, EPFL and MICC. The selected images consist of human subjects under different illumination and environmental conditions, time of day, and distance from the camera. The subjects are either far field, mid-field, or near field from the camera. A few sample images are shown from each dataset. In our paper, we have chosen limited number of images from each dataset. The limited number of images used in this paper represent associated complexities to acquire decent image frames as training set in various surveillance environments. For qualitative results, we used multitask cascaded convolutional neural network face detector. For quantitative analysis, we used peak signal-to-noise ratio, structural similarity index, Jaccard and Dice coefficients, and face detection accuracy. On the local dataset, we used all the 7 SR algorithms along with conventional zooming to showcase the results. The input image is 35 by 33 pixels in size for both subjects in the visible example. For our experimental results on locally acquired datasets, we used MTCNN and D-lib facial landmark detector. All the subjects are zoomed and super resolved 4 times. The super resolution depicted here is super resolution via sparse regression. It can be seen in a couple of cases where face detector is unable to pick up zoomed image but is able to detect the super resolution result. MTCNN was then applied on public datasets, keeping the criteria same as before, which is that all images were zoomed in super resolved 4 times. A white bounding box represents face detection. It can be seen that in all these datasets, the face detection either increases or is equal to in the case of super resolution as compared to zooming. For demonstration, super resolution via sparse regression has been chosen. Quantitative metrics are applied on all these datasets. In all the surveillance datasets comprising of different environment, different illumination conditions, and different number of subjects, SR2 which is super resolution via sparse regression and SR5 which is super resolution via convolutional neural networks outperform the rest. After applying super resolution through different surveillance environment conditions, it has been observed that super resolution algorithms not only depend on the distance of the subject from the camera, but face pose, environment and illumination play a key factor as well. Overall, SR5 achieved the highest scores on qualitative and quantitative metrics on most number of datasets. Super resolution via sparse regression provided best results under well-lit and low noise conditions. This is because textures and edges are preserved when the denoising parameter is small. Less lighting would mean higher value of the denoising parameter, hence edges and textures of the image are compromised. This is demonstrated in the 3 pictures below. Increasing the denoising parameter compromises the high-frequency information. As far as execution time is concerned, example-based super resolution produce faster results compared to self-similarity-based super resolution algorithms. Creating an external dictionary may take some time initially, but it generates a faster result during execution. This is due to the sparse nature of the algorithms, which converts image patches into a sparse linear combination of elements. For this paper, pre-trained weights of model-based super resolution methods have been used for analysis. The performance of these models can be further improved by training them on large surveillance datasets, thereby improving their performance on surveillance images. In this study, we have analyzed the performance of 7 state-of-the-art super resolution algorithms. The performance of these algorithms is evaluated on a set of images gathered from 6 public surveillance datasets, namely PETS, Caviar, MICC, and EPFL, having significant variations in lighting conditions and environments. To establish the effectiveness of each algorithm, we have used MTCNN face detector for quality metrics, as well as employed 5 different quantity metrics. Convolutional neural network-based super resolution model, even with a limited training dataset, proved to be the best algorithm as it achieved robust qualitative and quantitative metrics results as compared to other algorithms. This is because the 3 CNN layers progressively learn more complex features using external dictionary. The results further revealed that face detection of the subjects is not only dependent upon the distance and facial pose of the subjects from the camera, but the environment and illumination conditions play a key role as well, as they affect noise levels in the image, and the performance of these models can be further improved by training them on large surveillance datasets, thereby improving their performance on surveillance images. Moreover, latest generative adversarial networks-based super-resolution algorithms can be used to validate their effectiveness on thermal imaging modalities such as long-wave infrared and near-infrared.
Thanks, Ali, for the presentation. If you can, welcome Mohammad Ali Farouk. If you can please introduce yourself briefly, and of course, Ammar, if you can introduce yourself quickly so that we move over to the question and answer sessions.
Yeah, hi all. So my name is Mohammad Ali Farouk, and I have completed my bachelor's and master's in electrical engineering from Pakistan. Currently, I'm pursuing my PhD in electrical and computer engineering from National University of Ireland, Galway. And I'm working on safe autonomous driving systems as my research project. It's a consortium project and funded and supervised by European Union. And I'm also affiliated with Xperi Island and Xperi US teams as industrial partners. So that's all from my side, and Ammar will introduce himself now.
Okay, yeah. So hi everyone, my name is Ammar Ali Khan. I've done Masters in Electrical Engineering from NAS, Pakistan. Currently in the last couple of years, I've been working in the FMCG sector. I'm working in Unilever in the supply chain department. So my interests include computer vision, And even in my field of supply chain, I'm trying to inculcate the image enhancement techniques and computer vision techniques in our day-to-day work as well. So yeah, that's a brief introduction about myself.
Thank you so much, Ali, for the introduction. And we'll wait for a couple of seconds by the time we get some questions from the audience. Possibly the dimensions of the expansion, which being a co-author of this paper as well, we like to see that. How do you see that the trade-off of using external and internal dictionaries in here, and if you have touched upon the patch size and the execution time, how do you see that it is going to affect the super resolution process?
Okay, so as far as execution time is concerned, I think it is very much dependent on the patch size. Higher the patch size, if the image size and the patch size. So if the image is the low resolution image has a higher resolution, then it will take more time for image to enhance, and super resolution would be more computationally expensive. Similarly, if the patch size is low, then it will take more time to execute the results. So lower the patch size would mean higher the computational cost. And if my image, if my input low resolution image is at a higher resolution, then it will take more time to execute the SR results as well.
Thanks. I think we do not have any questions up till now from the audience. So let me grab this opportunity and ask another one from you guys that, okay. There is one question coming from the host, Marios, that how the method deals with noise.
Okay, so in the conventional super resolution algorithms, we have the L1 and L2 denoising, L1 and L2. We have L1 and L2 parameters, which converts patches into a sparse linear combination of elements. That algorithm uses an denoising parameter lambda. So let's say if I have an image which has a higher amount of noise, I would need the value of lambda would increase, and meaning that my value of denoising parameter would increase. So what it does is that when the image input low resolution image has a higher amount of noise, I need to increase the value of lambda, which means I have to increase the value of the denoising parameter. What it happens is that the higher value of lambda would equate to it would compromise the higher frequency elements of the image, which means my textures and edges of the images are compromised the more value of denoising parameter that I use. So to answer the question, so there's a denoising parameter using an L1 and L2 norm minimization method. And what it in turn it does is that the higher the value of the denoising parameter, the more compromised my image becomes because of the textures and edges.
Okay. Since we have a couple of minutes, so let me grab this opportunity to ask one more question, that why the generative adversarial networks GANs-based techniques, being neural network-based, why they are not able to produce some good results compared to the conventional machine learning methods that has been used in the paper.
Yeah, so I will go for this. Basically, like, yes, as we told that we have used GAN networks and other CNN networks, but unfortunately GAN networks were unable to achieve good results in case of most of the data sets like Caviar, EPFL and EPF3, because this is just because due to the poor interpretability and the small sample sizes. Other than that, if you can see that we have specifically not trained this network on the surveillance data sets, we have used just the randomized weights of this model for our purposes. So if we specifically train this network more specifically for the big surveillance data sets, of course, it will give us some more robust results in our applications.
Okay. I think if there are any other question coming from the audience, that would be great. And otherwise, I think so to apprise the audience a little bit of, if you can touch upon the single image, single output, the multiple image, single output, and the multiple image, multiple output concept, that will be great. That if somebody is interested in the surveillance environment and how what is the best choice for these input images? Why not to use the multiple images compared to a single input image? Specifically, if we are talking about the surveillance screen.
Okay, so basically in multiple image super resolution, which you refer to, requires multiple low resolution images to produce a high resolution result. But the image shift between the two images should be at a subpixel level, meaning that image A and image B should be at a 0.5 degree shift in order for that to execute. Now that we are talking about the surveillance environment, the subject or the people are moving at a very random position. They are not moving at a subpixel level. When they're not moving at a subpixel level, therefore in the surveillance, because the movement in the surveillance environment is very random, therefore our multi-image super resolution algorithm does not provide a good result. It does not provide a substantial result. Whereas single image super resolution algorithm, what it does is it just requires a single input low resolution image to produce a high resolution result. As I said, this can be done through external dictionaries or internal dictionaries or through neural networks as well. So in our case of super resolution, in the surveillance environment, where we know that the person is moving randomly, there are occlusions as well. The person is not moving at a subpixel level. Therefore, I think single image, we opted for single image super resolution algorithms.
Okay. Thanks, Amar. I think there is one question coming from Jaswati. The question is how to use fairness to check evaluation, evaluating the GAN models. How do you use the fairness to check of the GAN models, so you can actually
So basically, can I go?
Yeah, please.
Yeah, so basically, as you know that GAN networks comprises of two main networks. One is like generative network and one is like discriminative network. So the generative network is generally used for generating new sample data sets or for performing the super resolution using the low resolution animation. So in order to check the fairness and in order to check how well it is performed, we have to well train our both generative network and discriminative network. So we can work with different loss functions and we can work with different optimizers. I think so. Like the network we are using is trained with Adam. So Adam optimizers. So we can work with SGT and Adam optimizers. Both can be used to check how well the network is trained and how the discriminative loss and how the generative loss are going. This is the best possible way to check how well our network is trained. So that's in this way we can check the fairness of the networks.
Thanks, dear. I think we have another 1 minute left for. The message is like we will have another 10 minutes of a breakout. We will have another 10 minutes in the breakout rooms. If anybody has some additional questions, they can actually are welcome to join the breakout rooms. And we are already approaching the session ending time. Thanks, Amar and Ali, for joining and presenting your work here. So with this, I will officially close the machine intelligence session 2. Thanks again to all the authors and the participants for attending the session. I hope you have gained something out of this. All of you are invited to meet the breakout rooms, which will be there for each paper. And next, we will have the modern technologies and solutions to support your cities by the Institute of Logistics and Warehousing, Poznań, Poland. And taking this opportunity, I will also like to thank all the sponsors and organizers of the MIDI 2020. While we are waiting for normalcy to return, like the old normal we used to have in this world, we hope to meet next year with a pandemic-free world. Stay safe, all of you, and see you all. Thank you.
Great, thank you, Dr. Raza. Thanks for chairing the session, and thanks to all the presenters. I have one remark regarding the paper about placement of a restaurant branch. And there is one thing that if anyone of you decides to open a restaurant branch, I would not recommend Moon. Even if the food is great, there is no atmosphere. So fortunately, We have a great atmosphere here and MIDI. And before we go to the next event in our agenda, like Dr. Raza said, we have open breakout rooms for questions to the authors, and at the same time we have an open room for meditation. Yeah, we just yesterday we came that we to the conclusion that we should name our meditation session meditation, and actually I don't know why we haven't came up with this name earlier. So as you see, there are also social breakout rooms, and before we go to the next presentation by the Łukasiewicz Research Network Institute of Logistics and Warehousing, the presentation will be on urban mobility. We have 10 minutes. We will have it will shift the session from the Łukasiewicz network by 5 minutes, as far as I know. So we can meet here 20 past 12. See you in a moment. Okay, and we are back, and currently we are starting a panel of presentations by Łukasiewicz Research Network Institute of Logistics and Warehousing. The topic of the presentations will be urban mobility, and the chair for this session will be Marta Cudziło. Marta, the floor is yours.
Hello everyone, my name is Marta Cudziło. I'm from Łukasiewicz Research Network from Institute of Logistics and Warehousing. I'm a head of Logistics Development Center, and today we would like to, with my colleague Victor, tell you something about EIT. Why EIT? Because in our opinion, it is great space for creating innovation. Also innovation connected with machine intelligence and digital interaction, because urban space, it's great space for innovation. That's why let me show you some presentation. I will give you some information about EIT. Okay. I hope everyone can see my presentation now. Okay, so my presentation will be only some introduction about what is EIT urban mobility, and then my colleague Victor will give you some details about our projects which we develop in this area. But EIT, what is it? EIT urban mobility. So maybe the first I will give you some facts which prove that urban space, urban mobility, it's a great space for making some innovation, for solve many problems, because we have, as you can hear, as you can see here, some facts. For example, 72% of total CO2 emission is in the European Union come from road transport. Also, 61% of citizens face traffic jams every day. 30 hours a month spends 30% people in a car in a traffic jam. And as you can see, it's a very urban space. It's a space with many problems. That's why, as I said, it's also it's a great space for making some innovation. And here you have European Institute of Technology. It's the full name of EIT, which I have mentioned about. It's European Institute of Technology. It's some organization with headquarters in Budapest. It's an integral part of Horizon 2020, and it's some organization which was made to solve some problems in some specific areas. And that's why now we have EIT Climate, EIT Digital, and also EIT Urban Mobility. And this part of those organizations is the part which is which we are interested in. EIT brings some solutions, and it makes some triangle, let's say, from business, from education, and from research organization. It's for making innovation, for create some projects, some solutions for this area. EIT now, it's a very big organization, because as you can see, this organization in numbers looks really great. 6,000 jobs created, also big amount of money invested in some projects. So as you can see, it's not a small project, but very big project concerned with urban mobility problems. Here we have some conclusion that EIT Urban Mobility acts to accelerate positive changes in mobility, to make urban spaces more community friendly. So it's not only for business, it's also for citizens. It's some accelerator of for different types of people and organizations. The goal for EIT Urban Mobility is to become the largest European initiatives to change urban mobility. That's why now we have many cities in this organization, also many business, many companies. Here you have some also conclusion. Now we have 85 major partners, and those partners represent, first of all, industry, but also knowledge institutes and universities, but of course also cities, because urban mobility is for solving problems in cities. That's why some cities should be the main participant in those organizations. And of course, it's true, we have Hamburg, we have Eindhoven, and other European cities, as you can see here, but also big amount of companies, big amount of universities, and also we, as Institute of Logistics and Warehousing, we are also part of this organization, and we want to create some projects, very innovation projects. EIT has some regions in Europe, because Europe is very big. That's why it's some plan to organize these activities in some geographical regions. Maybe it's not the most important, because it's only some plan to share the whole Europe, but here you have information what we can do. We bring all the key players in urban mobility, so also companies, universities, and so on, in urban mobility together, and encourage them to co-create. So also city challenges are at the center of everything we do. It's true. And we in EIT stimulate behavioral changes that benefits people and cities by engaging citizens and transport users from the word go. That's why it's for everyone. And here you have some information about organizational information about who you can be in this organization. We as the Institute of Warehousing, Logistics and Warehousing, we are a core partner. Level 1 is the highest level of participation in EIT, and we have big place to create new projects in this area, in the area of urban mobility. But also we can cooperate with business, with companies to create new projects. And urban mobility, it's a very big area. That's why we create some, let's say, smallest areas, some smallest space defined as challenges. And we have also some schedule which we cooperate. Now we are during the process of the ideation process, which means that we create and refine challenge areas. And by the end of the year, we want to have 5 challenges. And we, the EIT organization will publicate the call, and it will be a great opportunity to making some projects and to get some financial some money for those projects. And those areas, those challenges, first of all, we have 9 areas, then we have only 7 because those 2 wasn't so interested, the most of companies wasn't interested in those 2. But for us, active mobility and sustainable city logistics is the most attractive area, but also we have future mobility, mobility for all, and so on, as you can see here. And in those areas, we create projects. And now we have 2 specific projects in those areas. When we create some innovation for urban mobility. The first project is connected with urban consolidation centers, some specific places, and the second one is a project concerned in intelligent unloading base. Those 2 projects are developed in this area of urban mobility. And now let me introduce Victor, my colleague, who will give you specific information about those 2 projects, and you will have opportunity to ask him also about some details from those projects. So thank you for your attention, and let me introduce Victor. Victor, please tell something about those 2 projects.
1 second. Okay, can you hear me? I hope so.
Yes, Victor, we hear you.
Okay, can you see my screen?
Yes.
Okay, so let me start. Marta has introduced the project. First of all, sorry for the window in the back of me because I was forced by my family to move to the different places like before. So that's why I'm at a little less comfortable place. I hope I'm not so beautiful, so you are not losing much. And I want to talk about 2 projects Marta has introduced. So the first one will be the IoT-enabled urban logistics smart reloading base. And the second one, project connected with mobility hub, consolidation hub study, pre-feasibility study in Poznań. Okay, so again, that will be different. I've made the 2 different presentations, separated presentations, and I will start the first one. Then the first agenda is, like you can see, the city realities, the projects we are involved, a few words, what do I understand, how I understand the Internet of Things. And finally, the real concept and its implementation, and expected output and limitations as things which are put in the opposite. City realities. I think all of you know that traffic in the city is very, very tough, and usually up to 30%, according to different sources of literature, have source from the traffic of trucks, of the cargo vehicles, and this is the fact. This cargo vehicles, this van, these trucks lead to difficulties because of the limited number of space and problem on the streets, not only on the parking, but only but on the driving when moving the cars too. So the three different point of view in this problems with the traffic in the cities are: first, trucks which are generating traffic by moving, trucks generating problems by maneuvering, and trucks during the loading and unloading process. I think which is the most important, especially in the congested cities. And there will be some examples from the Polish cities. The first one shows the cargo congestions. You can see two vans and some goods unloaded on the right side on the narrow street in the Poznań. So this is one of the examples of the problem. The second is that the drivers are so desperate. I mean, the drivers of the trucks are so desperate that they are deciding to unload just on the street, and you can see the private car crossing the double line, which is not allowed, I think everywhere, not only in Poland. And things we have to consider that when you are moving the pallet, you need to have the flat space, and the curbstones are something you cannot cross with the pallet. So you have to think that the reloading base should be prepared for the reloading pallets. And this is the example from the Kalisz Street. And to tell you the truth, this is the picture from the Google Maps. And the van is standing in this position because the driver has direct access to the level of the pavement, and he don't have to cross the curbstone or curbstones in case he will stand on the opposite side of the street. And this is the picture from the Poznań, the same from the Google Maps, and you can see two parked couriers vans, and the street is only for trams, open only for trams. So usually there is no place for parking and no place for unloading, but the couriers are forced to do it to supply packages to the customers. And one more thing, we can see the van which is parked properly on this unloading bay or reloading envelope. And in this case, it is a little bit too long, and unloading is only possible from the side of the van. And this means that some of the bays, if they are prepared, were poorly designed. And of course, I think the most important problem with the envelopes of the bays are the private cars, which are using the envelopes for reloading for cargo traffic as the parking places. And this way, the unloading is impossible in the right location. This is the normal situations. So that's the reason why we have started two projects. I think the introduction from the second one will be exactly the same or very similar. But okay, the first one, so this is IoT based, so the places for unloading. And I will talk about two projects because we are in the at the stage of implementation of the second one. The second one is made in the scope of the IoT urban mobility. And we are cooperating with the Poznań as a city, and with the University of Maribor, and with the Łukasiewicz. This is our mother company, mother institute, the research network. And the second project, which was implemented, I think, two months ago, and we are starting the process of testing and piloting this project, is project made in the scope of the Sprout project. And this is the project, research project under the Horizon 2020. And in this consortium, we have 30 partners all over the world, because we have partners from States and from the China and from the Israel, and of course a few partners from Poland. The SPROUT means Sustainable Policy Response to Urban Mobility Transition. Marta said some words about IIT. I can say you something about the SPROUT. The main objective of the project is to identify and implement new operational and business models for public and private transport and solutions for urban design and planning. Of course, you can find, I haven't said about that, some information on this site, SPROUT, Civitas EU. It is easy to write it down if you want to have more information about the project. One of the work package in the project was to prepare some pilots in 6 completely different cities and completely different projects, different pilots. So some are connected with the freight, some are connected with the passengers. There are 6 of the group of 6 of the cities. One of that is Kalisz. We've got some cities from the Italy, Hungary, Israel, and I think China. And this is the consortium for our pilot. Pilot made or under test in Kalisz is made together with the Kalisz city and the business incubator from the Kalisz city too. As I said, the first one, the project in Kalisz was started. I mean, the application of the project has started, I think, 2 months ago, and we are testing it. The second installation in Poznan is just under construction. And how I understand, how we should understand the Internet of Things. Okay, so the easiest definition is just a network of interconnected objects. But the very important is information that the objects are communicating without our human intervention. And I think the easiest definition I found on Wikipedia page is a network of physical objects called things that are embedded with sensor, software, and other technologies for purpose of connecting and exchanging data with other devices and systems over the internet. I think the internet is not necessary here, and I think there should be added information that without this human intervention, which is very important. So we don't have to put on the internet, I mean, the connection between the things or objects can be made in different way, even by wire. And the concept of the IoT base and the implementation of it, the next step. So this is the picture showing the example from the private cars, but the idea is very, very similar. So we've got the parking places, or in case of the traffic, cargo traffic, we've got the base or envelopes. I call it reloading base because you can load and unload the trucks there. On the bay is located the sensor. The sensor or sensor, if you've got more of them, are communicating the information from the sensor to the gateway or base station. The information is only in this case, yes, I have car over me, or no, I don't have the car over me. So there are 2 possible solutions. There is no information about the number of plates, so it is the cargo van or it is the private car, just the information that the place is occupied. The information is sent to the cloud. In our server, in our situation, we got the server, not only the cloud, and then we have application. The application, the database allow us to interpret the data, so we know that the place is occupied. From the data, we can know that the place was previously booked, so we know that it is occupied by car who has, or the driver who has booked the place. And we can share the information with anyone who have the application installed on the mobile phone. And the drivers or even normal people can see that this place is occupied or not occupied, or is occupied with a reservation or without the reservation, or that the place is booked. This is the main idea, and the steps of the project very similar in case of the Kalisz and in Poznań. In Poznań, it was a little bit shorter time to prepare, so we have cut this scope. But first thing is to identify and location and potential of base, because we have to know which location is good and how high the potential for this place, how many reloading operations can be done on this location. So incubator of business from Kalisz have prepared, has conducted the research in the potential customers of the people who are supplying by this reloading base. Then after this gaining the information from the research, we have made some calculation, we have put it on the map, we have found the location where the base should be located. In Kalisz, there was two new one, and one was existing one, which was censored. In Poznań, we have 50 existing base, so it was easier to find a good location, and there was a little bit different way to decide, because we got in Poznań we got some kind of subscription for the base, and the base with the subscription was indicated as that for sensor, adding the sensor. Then we have to construct or prepare the system. It was, I think, the easiest way was just to put it on the right places, but we have to make some tests. We have take this different base station, different sensors. Our technicians have made the tests, which are the best one, and we have chosen the right equipment. I mean, the base station and the sensors. Which were communicating, I think, in our opinion, in the best way. In Kalisz, we have the base station only one located on the city hall tower. You can see the building on the picture on the right, and the project of the allocation of the base station very high in the Kalisz situation, quite high, because there is no very high building around. So it is, I think, the best place with the best access. And here is the situation in Poznań, which is a little bit different. One of the base stations is located in the building under the roof. And from our point of view, this is the problem, because the roof is have the negative influence on the range of this station, and we are just making the connections and changes now. And the second thing are the base. As I said, in Kalisz, there was two new base prepared for the project. One was added from the existing ones, and the project from the city services have to be prepared. And the project looks like that, and this is the real picture from introduction of the signs on this base. The problem is the same in Poznań, like in Kalisz, that the center is the historical one, so especially the city hall is historical one. So we had to have some permissions from the appropriate services to allow us to install and sensors and the base station, the same in Poznań. And of course, the last thing to put is the sensor. We have chosen that sensor, the Bosch solution. It was from our opinion the best connection with the LoRaWAN base station at gateway. That's the reason. To tell you the truth, the range of the base station theoretically on the open space should be even 10 kilometers. In Kalisz, we have made it 500 meters only. In Poznań, it is even less. I will maybe tell about that a little bit later, more about a little bit later. And you can see the picture from the Poznań street, and you can see the sensors on the curbstone. You can see the trams, and you can see different surface types. So we've got on the road, there is the historical cover. On the left side, we've got the, let's say, 10 or 20 years old pavement, and it is not easy to locate the sensor on the historical parts. So we have decided to put it in this case, as you can see on the curbstone. And of course, things which is the interface with the drivers, with the people, and you can see on the right side that there is a map with location of the base of the envelopes. We call them envelopes tube, and this green one are sensors. I will just give you information. What does the color mean in a minute? But by the application, you can find the location. You can book the location. I mean the bay, make the booking. When you are going to this place, the application is sending confirmation: is it you are parking? In this case, you are just the person who has parked in the right place, and you are confirming it. And in Poznan, it is quite good situation for this application, because we don't have to think about the payments. In Kalisz, the driver have to go to the machine, just buy the ticket in the machine. In Poznan, the drivers who pays the special subscription, which is not expensive, for a location, can park there. So the person, the number, you've got the list of the number of the phone of the person who can book the location. Other drivers can just check where is the location of the base, and which are occupied, which are not occupied. And we've got 4 statuses of the base. You can see on the right side the 3 different colors. The 4th one was not easy to reach, so that's why it's not on the picture. So the red means that the place is occupied without the booking, so the booking is unauthorized. The orange means that at this place, at this moment, for this moment, the place is empty but booked in application. The violet is the color when the parking on this place is confirmed by driver who has made the booking. And the green one means just that there is the empty and ready to serve bay for drivers. And this is the whole Poznan city center with the 50 locations of the base. You can see that 4 of them are occupied. In this scale, we cannot see all 4. I think 5 is occupied. Sorry, 3 are free. And this is the normal picture or screen seen by users of the application. And implementation and test. To tell you the truth, in Kalisz, we haven't got any problems with the installation. We have just put the base station on the city hall. We have measured the locations with where was the dedicated places for base, and everything was okay. All the base was in the range of the base station. And in Poznan, we had the little bit different situations, because the base stations are located lower. I mean, not so high as in the Kalisz, and the city buildings are higher. So even in the places where we have measured the reach of the station, we have the problems with the connection with the sensors with the base station, especially when you are driving the car over it. So if the car is standing over the sensor, the reach of the sensor, the range of the sensor is lower. So we have to move some sensor closer to the base stations. It means that in case we would like to put all the 50 base with the sensor, we need to put, I think, 10, maybe more base stations just to cover all the city with the range of the base stations. And what we have reached and what are the limitations we have identified till now. Okay, so. Okay, on the right side, you can see the base station on our building, the building of the institute in Poznan. So the specific outputs are just the real information. So the driver is not forced to go to different places to unload the truck if he has information that the place is occupied. So if he can choose the different location as the first one to do the operation, and then if the place is empty, he can go there after the second or next reloading process. There can be make some planning. So the drivers can book the places a few days even earlier or a day earlier. If they are operating with the same hour, I mean, the more than one driver operating in the same hour, they can just make the reservation and just expect that the second driver will make the reservation earlier or later. And okay, there's additional option we have not implemented in the applications because there was not necessary in this case, but it would be easier for the drivers if they will have to pay for every parking operation, just to make the payment for the parking, because it will be made only once for all the parking operations. So I will check the time. And of course, the social, environmental, and economical improvements, I think, very easy to understand. So we think that the trucks don't have to go around the city looking for the empty places because they can make the reservation. So we can reduce the pollution. We can reduce the time and cost of flight operation. And we can more and better utilize the resources. Of course, the traffic will be, the safety will be higher because there should be less vans parked in the wrong places. And of course, if the traffic will be lower, if there will be less traffic, we can expect better attractiveness of these urban areas. And we have the data you can use for information. To tell you the truth, we wanted to force the information about the occupation of the unauthorized occupation of the bay by SMS to the local controller of the local parking zone. And I have this SMS tool for 1 day only for me. And I have received around 100 SMSs with the information that someone has parked on this place. So we had to turn it off because it was too many SMSs, too many information, and decided to ask the controllers to install the application on their mobile. That's why that means that there will be plenty of different parking action. So the controllers can have information just 30 seconds after parking that someone has parked in this place and the place was not booked. And the controller can just check and force the drivers maybe not to pay the ticket, but just to buy the subscription for this place. And of course, we think that if you have the results from the project, we can make some introduction to the information to the policies, to the local policies of the urban, just what to do, what should be done, what is the best solution, what are the results of our project, which can be implemented in the plans for the future. And problems, of course. It is not easy to force the person who are not using this application to do it. Sometimes when the drivers are parking only for a few minutes, just as I say, the couriers companies, they don't want to pay for it, they don't want to make the reservations. We have the problem of the atmospheric conditions because, as I said, that one of the base station is located under the roof. The roof is quite thin. There's no metal in it, much metal in it, but it can be covered by water. It can be covered by some frost. That's maybe the things which make have a negative influence on the range of the base stations. And the problem with the historic buildings, because the old cities center are usually historical locations, so we have the special permissions, and the project, this permissions process is quite long, and it takes time. We have only 3, maybe 2 months of the information how the sensor will survive on the roads. We are afraid the most unsnowing the surface of the road, so this will be the problem. Can be the problem with the sensor. But from my point of view, the glue, because the sensors are glued to the surface, is solid like a stone. We hope that the sensor will last quite long. And as I said, the drivers are not have something opposite to use the hardware, especially that in case the user they have to pay for the location. And to tell you the truth, during the installation of the sensor, we have find out that some drivers from the courier companies haven't got the budget for parking, so they don't have the money to pay for the parking. On the other hand, there are some shops in the city of Poznań which are opening, and the owners of the shops are obliged or forced by their bosses, by their mother companies to subscribe nearest base. So there are completely different way of thinking. So someone is trying to avoid in every possible way the payment, and others are paying just to have the place to have the possibility of safe reloading of the vans. Okay, the next step, we want to have some recommendation. We have to have some information from the system, the test, and we will just have maybe more experience in this area, just to give the information if it is a good idea. It will be not only our experience, but experience from the city, part of the citizens, from the users of the applications. And maybe we can give the information that this is the good solution and it can be implemented in different cities and different places. And as I said, the second project is a little bit different, but have the same background. So the same background is that we have the same reality in the city. So the trucks which are going around, but the solution is completely different. The solution is the urban consolidation center. And I will just go through this presentation to show you what does it mean in my relations. So the urban consolidation center is the place with the appropriate logistic infrastructure close to the area which it serves. And this is the area from that should be made the local last mile deliveries. And it should be close to this location of the city. You can see on this picture how does it look like. So we've got different suppliers here, the different products, but we can have different suppliers with different things. So we can have different couriers companies, different companies who are supplying to the shops. We've got this urban consolidation center, or we can call it hub. Then the share truckload transporting the goods to the retail location. It don't have to be shops. It can be restaurants. It can be different places, some service places, and this is why. And especially the last mile delivery in this case can be made by low emission or zero emission vehicles. And there are different possible form of operation, and there could be the owner of the company, there could be some rental space, and the part of the space can be rented. There can be the shared investment, so a few companies can make the investment altogether. Of course, the public-private partnerships, and the place owned by the city and then rented to the operator. And additional thing which is important, especially here in Poznań, is that in Poznań was indicated or will be indicated in the near future the clean transport zone with the access only for let's say green vehicles. So there will be reduction of the traffic of the vehicles with the high greenhouse gases emissions. And of course, it will be the city of the center for the first step as the historical one. And the strategy is based on the act, national act, forcing the cities to prepare this kind of the zones. And this is the part of the zone which was what was decided by the city to make this zone in the city center. We've got the second part altogether. It looks like that, and in this case, this give us that this is not maybe very huge area, but it give us the information from the calculation and estimation that the supply to these areas will be around 300 pallets daily. It's quite huge number of trucks. If you think about the huge trucks, the 10 of them, because you usually have 33 or 33 pallets on it. So it's quite small area, but plenty of goods are supplied there. And now on the slide, you can see the real historical area of the Poznań city center. So we think that in the next 10, maybe 15 years, the area will be higher. And so we will have maybe not 300, but 600 or even 700 pallets supplied to this area. This is the map with the noise emission in the city. You can see that the historical city in the center is not so noisy because the traffic was reduced to this old market square, and you have to have a special permission to go there, and it is existing now. So we can expect that this area without this noise or the lower level of noise will be wider or bigger. And in Poznań was initiative to start this urban consolidation center, and because one of the reason was in the strategy of Poznań, and that the Poznań should support the activities connected with this, let's say, consolidation hubs, urban consolidation centers, and this way try to find the solution, try to reduce the traffic, especially the traffic of the dirty vehicles in the city center. In the activity was involved the City Poznań, the company Rolling Sus, which is the operator, should be the operator of the hub, Volkswagen, which want to supply the aircraft or cars, and of course we as a research institute. The assumptions are that some of the recipients and groups will be supplied directly from the hub. We don't have, I mean, the hub cannot change the quality and reduce the level of the service in the city. There should be used only the low emission vehicles. We think about the electric car or even electric bikes. Of course, the problem is that we have to take into consideration the direct return transport of, for example, usable packages. Okay, there are some incentives which will be prepared according to Polish entries in the Electronic Act, which was I think introduced a few months ago. But the act gives only a small amount of money to pay. This is the, let's say, half of the euro per hour. So it's not very high value of money for going and into this zone for, let's say, dirty cars. And additional one that city can add additional payment for parking of these cars into the zone. So this is the only two financial incentive to use hub or the consolidation center. Free parking for the electric car, yes. And of course, if the hub will start and it will be trusted, so it will be just the information that it will be made. I mean, the last mile will be supplied very good and done in good quality. We don't know if it is enough to convince the companies to use the hub, to use the service of the last mile. We expect, so we just making the calculations how much it will cost from the other side, because we have to, I mean, the hub have to take some fees for supplying last mile. And expected expected benefits and limitations. Of course, they are similar like before. So reduction of the vehicles, reduction of the pollution, better coordination, we think, improving delivery reliability, and of course, which is the most important, the lower emission. And we think that it should be done, or it have to be done without the reduction of the quality of the last mile delivery. barriers. I think the most important barrier is the plenty of different IT systems. When we think about only about the couriers, everyone have different system. You can pay by card, so you can pay by cash. You can sign something on the screen. You can sign something on the paper. And there's completely different way of supplying, resolving this last mile deliveries. So it will be very different to find the solution for one supplier, for one operator to just gain this IT system into the one. Different delivery schedules, and for example, some companies offer the deliveries before 9 in the morning, some offers delivering after 5 p.m. So there will be completely different ways of making the business, and the consolidator center have to be prepared for that. Different parking dimensions, okay? There will be surprised the things from the size of the letter to the size of the pallets, only were higher because someone have to buy something bigger. But as a standard one, the letters and the pallets, there are two dimensions from the smaller side and from the highest side. Of course, the problem will be with returnable packaging, with the returns of the goods, because you have to always return the good if you want. Of course, the cash, the financial calculations, transferring the cash. This is the problem have to be resolved, and of course the problem with the cost, because the operator have to cover its costs, have to earn something. On the other hand, the people who are living in the city center don't have to pay. Don't want to pay more for supplying, because they're living in the historical part of the city. So this is the solution, to find a cheap service which will not add additional cost for delivering the packages or the pallets. And finally, the problem is with the solution that there is not many examples of existing urban consolidation centers. Paris has tried Distripolis, and there is some description of this solution. There was not only one hub, there was only, let's say, there was one huge hub or huge consolidation center, a few small ones in the city. And we know about the similar installation, similar system in the Lucca, port of Lucca. And maybe a few more. I know that something was prepared and tested in States, but it's not so many examples, which means that this is not easy to prepare this initiative, sorry, to the end. Thank you very much. I hope Marta is with us. I don't know if I'm good with time. Marta, can you hear me?
Yes, I'm here. Yes.
Thank you very much. We are 5 minutes before the time, so you have time to say something.
I just want to say that our time is running out. That's why, as a conclusion, I think that we would like to say, maybe not say, but invite you to cooperate in this area created by EIT Urban Mobility. As you can see, we can create very nice projects, and it's also good space for innovation, as you can see also. EIT also give us space to get some financial support, and that's why it's very great proposition, I think. So we invite you to contact, to create some projects with us. We are a core partner in this organization in EIT Urban Mobility. That's why we have great chance to create projects and build some consortium for those projects. That's why, as I said, we invite you, and we hope that our presentation give you good and nice information. So it's all from us. Maybe you have a question. I don't see any questions, but
I hope the host of the conference is here. I mean, the host of the conference, not only me. we can.
Yeah. So our invitation will be for you will be our conclusion, and we will give the voice for the host, I think.
Okay, I hope you can hear me now. So thanks again for a very interesting presentation. I hope that next year we will see the fruits of a collaboration within this project. And now we can smoothly move to our last paper presentation sessions for this day and for the conference, in fact, which will be a digital interaction session 2. The host for this session will be Dr. Katarzyna Abramczuk, researcher at the National Information Processing Institute and University of Warsaw. Katarzyna, the floor is yours.
Hello, everyone. I'm really happy to be here. First of all, I wanted to say I'm very happy to be part of this inspiring event. We have one more session left, and this is a session about digital interaction. There are a few very interesting papers before us. The first one is about learning online. One is about crowdsourcing in the business processes. One about voice user interfaces for older adults. And there are 2 papers on remote work. We will start with the first presentation, which is a learning analytics case study, relation of students' learning approach to online learning environment behaviors. We will start by listening to the presentation.
Hello. Our paper is a learning analytics case study, relation of students' learning approach to online learning environment behaviors. We examine the learning analytics in this paper. As an overview, we will explain the introduction, summarize about review of literature, then mention the purpose of the study, research design, methodology, and lastly we will explain the result. The aim of this research is to examine the relation between the log data obtained from the learning platform prepared within the scope of this study and the learning approaches of the students. For this purpose, students enrolled in face-to-face internet-based programming courses in the Department of Computer Education and Instructional Technologies of Yildiz Technical University. There are 2 concepts in learning analytics, which are surface approaches and deep approaches, and we will discuss about them. The difference behavior of the approaches can be explained such that the main aim of the learners who take a deep approach is not to take high marks but to understand the subject. However, the main aim of the students who adopt the surface approach is to demonstrate the minimum performance expected from them. As a very quick review of literature, in 1976, Martin and Saljo created a study to understand the behavior of students. It was determined that students studied on 2 levels, deep or surface. They realized the differences of these level approaches. Akkapanauer in 2016 implemented a study about how to classify students' learning approach level. Inyasi et al. In 2016, they have measured the outcome of these types of learnings. The purpose of this study is to examine the relationship between the log data obtained from the learning platform prepared within the scope of the study and the learning approaches of the students. To get this aim, the behavior of students was obtained. Learning analytics was applied to obtain data and was compared the learning approaches. In research design, quantitative research types such as multivariate experimental research, questionnaire analysis, and scale study method were used. The platform, which was developed as an educational environment, was introduced to students at the beginning of the semester. Throughout the semester, the training was conducted through a platform. The research was conducted within the scope of the internet-based programming course. There were 26 female students and 35 male students in the class consisting of 61 students. Data were collected in various ways: survey study, questionnaire, and online learning environment. In the database, data is stored in 11 tables. 2 tables are used in particular for analysis. In the process of data obtaining, every step of the students is saved as a log. In total, 76,937 lines were recorded, 14 screens designed in the log table. To get the result, students were asked to implement performance tests which include midterm, project, and final grades. In the implementation, Mann-Whitney test and SPSS homogeneity test were applied. These are the important tables occurred from the results. As a result of the SPSS homogeneity test analysis, the sig value is 0.298, so the variances of the factors are homogenized. And it is seen that there is no significant difference between the performance and the approach take note factor level according to the two-way analysis performed as the dependent variable performance. Therefore, the study approach and note-taking behavior have no effect on performance. As a result, there was no significant difference between learning approaches and performance since p-value is 0.130. It leads to say that students who show a deep approach try to understand the subject with supplementary materials and they are academically more successful. This result is similar with other authors and learners who showed a deep approach spent longer time on the learning platforms. Lastly, learning analytics will continue to be an important area for obtaining highly valuable data about students. Thank you so much for your listening and patience.
Thank you very much for the presentation. I know we've got two authors of this paper with us, but only one will be available for the video. So can you please show up and tell a few words about yourself, please?
Hello. I'm so sorry, but would it be okay if I just don't open my video?
Yes, okay. If it's a problem, then it's fine if you just the voice.
Okay, thank you so much. So I'm the co-author of the paper. My name is Gözde Demirci. And if you have any questions.
Okay, so are there any questions from the audience? I can't see any, so maybe I'll just take this opportunity to ask a question myself. Because from what I understood from your paper, you were aiming to facilitate the working of online learning platforms in a way that would enable us to identify the surface learners and turn them into deep learners. Is this correct?
Yes.
And if so, I was wondering whether you looked at the dynamic aspect of your data, because if this is our goal, it would be good if we could identify these surface learners early on in the course and try to nudge them into the direction of deep learning. Did you look at the dynamics of the data?
As a dynamic of the data, can you ask it again? I'm so sorry, but I just lost that.
Yeah, so I was just wondering whether you checked at which stage you were able to identify the surface learners from the logs. Whether you can do it early on in the course so that you can then use some nudging to make them deep learners.
Actually, we have created a whole system to see the behavior of the students. And since in the literature, we are considering as the two behavior of the students, which is deep and service, we were just checking the behavior of the students for each courses and get their results from the course. That's why actually, instead of actually another co-author of the paper is here as well, and she answered as well in the chat part. So she says that in this study we try to detect at the end because we also need to see the results, I believe. And as a future work, they will try to work on detecting earlier in the classes.
Okay, thank you. So I've got one more clarification question because this was unclear to me. What elements and teaching materials were present in your educational materials? So I'm asking about such possible elements as video steps, article steps, quiz steps, etc. Or developing on this question maybe even further, do you see any potential to use this type of information, like time spent on various types of elements, to identify deep and surface learners?
In the courses, they have supplied the PowerPoint slides and quizzes, and they get the results from those, among things. And also, it is written that timestamps of when they open the slides and logged in the platforms, everything, it has like 11 tables from the data set. It is stored the behavior to see the behavior of the students.
Okay, do you think there are differences in how students use these type of materials, depending on whether they are surface learners or deep learners?
Well, actually, I have to, my co-author would answer this more easily, I guess. Can I just... Sorry for the waiting. I'm so sorry.
I can see that she writes that there was a difference between behaviors of these two groups. Yeah. Okay. So thank you very much for this presentation and for answering my questions. Now we will move on to the next presentation, which is about crowdsourcing. The title is Deploying Crowdsourcing for Workflow-Driven Business Process. This is a brief proposal. We will start by listening to the presentation itself.
Hello, my name is Rafał Masłyk and I'm from the Polish-Japanese Academy of IT, XR Lab, where we are doing research and projects using VR. But this time I would like to tell you about our side project related to crowdsourcing. The main goal of this paper is to integrate the functionality of crowdsourcing tasks with workflow systems. This is an attempt to expand the capabilities of typical business systems by allowing select process tasks to be performed by unlimited human resources. The presented conceptual work is based on the current international standards in this field, promoted by the Workflow Management Coalition. There are several definitions of crowdsourcing in literature, but characteristic element of crowdsourcing is the delegation of tasks to an outside crowd, which learns about it by means of an open announcement. Communication between employees takes place on the internet behind the power of the crowdsourcing platforms. This platform is a kind of mediator during the crowdsourcing campaign. In general, the concept of workflow illustrates how information flows between the various objects involved in its processing. In the narrower sense, it is the flow of the documents between employees who carry out planned activities. In 1996, Workflow Management Coalition published a terminology glossary related to this technology. The last version defines workflow as the automation of business processes in whole or part during which documents, information and tasks are passed from one participant to another to allow them to take action according to a set of procedural rules. The goal of this paper is entirely devoted to the proposal of extend the current standards with the necessary elements in order to allow the tasks to be carried out as an element of the process, not by designed persons from the organization, but by the crowdsourcing. Preliminary work was divided into two steps. First one was dedicated to considering the architecture of different types of crowdsourcing platforms, offering access to the selection of possible tasks and their presentation to the potential crowd workers. The second was an introduction to the terminology of workflow type systems and in the end the language of process definition. This slide shows the structure of the workflow systems according to the Workflow Management Coalition reference model, along with the indication of segments requiring modification in order to obtain additional functionality necessary to support cooperation with CS tasks. This is the classic scheme of an activity of running tasks using the state machine. After completion of one activity and when the state machine allows it, the users can proceed to another task and so on. In our situation, we assume multiple async execution of tasks C results from the different time in which an undefined number of people can start performing this task. This task is going to be crowdsourcing task. To sum up, these are the changes we propose to apply to introduce this functionality. The first change concerns process definition. According to the standard, this concept contains all the necessary information about the structure, constraints, tasks, types, rules, and other process-defining data. This definition is the basis for the operation and feeding the necessary data of the most important component of this architecture, workflow enactment service. In the case considered in this paper, the first change concerns the indication of a definition of the new type of tasks. We will call them crowdsourcing tasks. As the name suggests, it is to be available to any external entity, organization, or person as yet undefined in the user system. The second change concerns the task list manager, who we usually called Worklist Handler. This component is responsible for managing the interaction between workflow users and workflow enactment service. Its task is to take care of the work process within the whole process by interacting with the workflow enactment service by means of a list of tasks available in execution. Our proposal is as follows. Worklist Handler would then serve as an interface for undefined users in the workflow system to redefine a defined scheme for retrieving information about users, such as indication data, ID assignment, contact data, and any other data. It remains to consider the execution of the timely completion of the instance of the CS-type task. This approach to controlling the process requires another modification to the standard BPMS architecture. The above-mentioned modifications to the metadata of tasks should be further extended by the additional attribute of task, that is the duration for the CS-type tasks. And in this place, it should be noted that in the specific cases, a time rule may not be the best solution. It is easy to show that the user's work can be configured in such a way that no instance is completed before a certain time has elapsed. In such a situation, the system forces the termination of all instances started and the task is completed, but not effectively. The system automatically moves on to the next task, and we have a problem with the task not being performed, although formally all the rules have been fulfilled. To sum up, these are the parts of the current architecture of workflow management systems that need to be adjusted to allow for a crowdsourcing type tasks. Thank you very much for the listening, and we hope to continue this work in the future. Also, its implementation. If you have any comments, or if you would like to get involved in the implementation work, feel free to contact us via email or ResearchGate. Thank you very much. See you. Bye-bye.
Thank you very much for this presentation. As you have probably seen my photo, I'm one of the co-authors, but there are more of those with us today, so please join me on the floor.
Hello. Nice to see
Hello.
you, everyone.
Hi.
Hello.
Can you say a few words about yourself?
It was in the beginning of our presentation. We are part of the teachers in Polish-Japanese Academy of IT, and we are working as researchers in the XR lab.
Thank you. We are happy to take your questions now. If there are any questions, please do not hesitate to ask them in chat.
I'm sorry.
The dog has a question.
I cannot see any questions. I think the presentation was so clear that it does not require any further explanation. Okay, so thank you very much. In this case, we'll just move on to the next one. Thank you again. Yes, we can also take your questions in the breakout room after the session. So now the third presentation in this session, the title of it is Exploration of Voice User Interfaces for Older Adults. It is a pilot study that addresses progressive vision loss. And now we will listen to this video.
Hello, my name is Wiesław Kopeć. I'm an associate professor of computer science and head of XR Lab at Polish-Japanese Academy of Information Technology, one of the best technical universities in Poland. XR Lab is a transdisciplinary laboratory which conducts participatory research on human-technology interaction. In this paper, we report on exploratory research as a part of transdisciplinary cooperation within the research framework of COBO Association Living Lab and its research initiative HAZE, that stands for Human Aspects in Science and Engineering. This is a research lab collaboration initiative which brings together scientists and practitioners from leading innovative laboratories conducting participatory research on human technology interaction, such as Emotion Cognition Lab from SWPS University or Laboratory of Interactive Technology National Information Processing Institute or VR Lab of Institute of Psychology, Polish Academy of Sciences. In this study, we explored voice user interfaces as potential assistive technology. So the question was how voice user interfaces as assistive technologies remove some barriers related to access to ICT by older adults, namely to address progressive vision loss. We addressed this question based on two exploratory empirical studies with older adults, with direct end users' involvement. The first study was a preliminary study or initial exploratory study to identify some barriers related to access to ICT. It was followed up by another in-depth study of people who are gradually losing their sight at a later stage, at a later age. So the background behind this study or motivation relates to a recent development of voice user interfaces or voice assistants such as Alexa or Google Home Suite, which you can see as an illustration on the slides of this presentation. The development of this part of the IT market is dynamic and diverse, in particular thanks to artificial intelligence, machine learning, and natural language processing. Voice user interfaces and voice assistants are becoming increasingly intuitive and functional. Therefore, we, as many other researchers, started to thinking whether voice user interfaces and voice assistants are promising for older adults and also with special needs. So the question arose if and how voice user interfaces as assistive technologies may remove some barriers related to access to ICT. As I mentioned, we conducted a series of studies. First was an initial exploratory study. It was based on semi-structured exploratory sessions with mixed method group interview scenario and with direct participant involvement. This scenario consisted of an introductory session with voice user interfaces and hands-on presentation of Google Home in a setup connected with a smartphone and peripherals like TV set or set-top box and fan and light and so on. It was followed by free use of Google Home by several participants from our living club, I mean older adults whose mean age was 73 years old. Alright, so there was also a discussion during which the participants shared their opinion on how this technology and its application is for them and their homes. We gathered many interested insights on older adults' perception of adoption of new information technologies and also potential end users. In particular, older adults claimed that this technology, I mean voice user user interfaces and voice assistants, they are rather for them than younger ones, I mean younger adults, because they don't have time nor patience, I mean younger adults in the eyes of older adults, for such time-consuming conversation-based interfaces. All right, further details you may find in our publication. Those findings were reported at length by Kowalski and others at CHI 2019 in Glasgow at late-breaking work session. All right, so based on this first exploratory study, we did a follow-up pilot in-depth study in the area of people with progressive vision loss. Follow-up study was based on also on a semi-structured interview, this time with the participant with progressive vision loss. During the session, we explored a few new aspects connected to smart homes, media control, and assistance of caretakers in the context of need expressed directly by person with progressive vision impairment. In particular, we have gathered a series of new insights reported in our paper on using the computer, smart home application, familiarity and accessibility of design, making it easier for the caretakers, interactivity and fatigue function of language. For example, thanks to this follow-up exploratory study, progressive vision loss participants confirmed the willingness to use voice assistants to control, for example, the window shutters. However, they were concerned about the cost of such solution and reluctant to use it as a substitute of physical activity from fear of not getting enough exercise. Another fundamental insight which was different from the previous study with older adults without vision loss or without vision impairments was that for them there was no need to use voice assistants or voice user interfaces, for example, to turn on the lights, as lights, it's a quote, lights switches don't move. It means that they are fixed or attached to the wall and they don't move. And this is an example of another insight from this study. On the contrary, the most desired functionality was connected with using voice interfaces to find and identify objects or personal belongings that changed their usual position in the space, in the surrounding of the person, due to, for example, activity of other people like caretakers of housekeeping staff. The main benefit was also its potential to allow them to continue using their laptop or a computer as a central hub to control, for example, the music, the video and audiobook resources, as the use of voice assistants removes the need of physically find the CDs, DVDs and insert them in the drive, which is a precise task. Another important benefit was the shortened setup, for example, of screencasting from a laptop to a TV set, which is now problematic and involves multiple steps, which also require physical precision. As a summary, we would like to propose some consideration for next steps and further studies. For example, first of all, can the use of such solutions spread organically? That is, will the older adults with disabilities such as progressive vision loss share their opinion about voice user interfaces with other older adults facing similar challenges? And the second question, would the introduction of voice assistants to people losing their sight be a factor discouraging them from learning new useful skills such as Braille? And if so, can voice assistance technology become a full substitute for other solutions and skills used by the blind, provided the users can change some of their habits, for example, use VOD instead of a cable, and learn specific commands, of course. So the last question is therefore the last question is to consider in further study is should voice assistant technology be considered as a new promising primary interface of assistive services for the blind, or should it rather be seen as a supplementary measure? Thank you for watching, and let us know what you think now or later on ResearchGate or via email. Thank you so much.
Thank you very much for this presentation. It was very interesting. I'm asking now all the authors who are present with us to join us on the floor.
Hello again.
Hello. I know we are still missing someone.
Yes, we are.
Where are you guys?
All right, you're here. Yeah.
Got it.
Ready for your questions or during the break. I mean, in the break room. Yeah, breakout room.
Yeah,
So
are there any questions to the authors? Please do not hesitate to ask them.
you might ask us on the chat or later on in the breakout room.
Well, if there are no questions, then I will ask my question.
Oh.
Yes, I have one. Because when I was reading your paper, it struck me that the problem with this target group, the older adults, seems to be that they have to form new habits to use new technologies. And the person you talked to seemed to be not very keen on changing his ways. So I was wondering whether you think it's feasible to encourage habit change in this group of people, and if you can think of any solutions that could help with this process.
Yeah, it's a tough subject. I mean, we are talking not we are speaking of people who are not let's say blind from their from entire life. Yeah, they are progressively are losing their sight. So this is something which is first dynamic. So there's no one clear answer how to engage those people. It's a really challenging question, and it's open question. So we are now focusing on better tackling this question in further research. So we don't have yet the clear answer. I think that during the follow-up studies, we will try to figure it out how to do a kind of a segmentation of attitudes and also the progress of the losing sight, just to better address various attitudes and approaches to engagement of older adults into this new assistive technology. On the contrary, it wasn't such a clear statement that the person was reluctant. I mean, they were eager to use this technology in some aspects, but it was really it could be really challenging in practice, because this was like an exploratory study. So in the further study, I mean the longer study, perhaps we will discover how to tackle this challenge.
Yeah, I was thinking also that like they were really eager to not rely on their caretaker too much.
Yep.
Like they mentioned that they don't want to be a burden to them. So perhaps like having that caretaker help them, like introduce them to the technology, would be one motivation.
Yeah, and
okay.
And this is there is also a question, so we can on the chat. So maybe we can...
there's maybe I'll just read it first so that everybody knows what it is. Kamila Maximovich asked, can you share some more insights and surveys you have conducted about the topic?
Yeah, so there is plenty or a bunch, maybe not a plenty, but a bunch of insights that we already reported, and we also prepared follow-up study. So we think that someday we will have another report on our progress in our research, and then we will share our results and also tools that were used in follow-up studies. So we can also discuss it in the breakout room.
Thank you. This was very interesting. Now we will move to our next presentation, which is about co-presence. The title is Co-presence and Well-being in the Time of COVID-19. Is a video call enough to be and work together? Please turn on the presentation.
Good afternoon, my name is Justyna Świdrak and I'm going to present results of a pilot study carried out last spring together with Grzegorz Pochwatko and Piotr Matejuk. The topic of the presentation is co-presence and well-being in the time of COVID-19. Is a video call enough to be and work together? The term telepresence was used for the first time in the context of teleoperation by Marvin Minsky in 1979. Since then, telepresence evolved and new concepts emerged, including social presence and co-presence. Co-presence was first defined as a degree of person-to-person awareness which occurs in the computer environment. People perceive some media as having a higher degree of co-presence, like video, and other media as having a lower degree of co-presence, like audio. Usually those with a high degree of co-presence is seen as being social and personal, and the one with a low degree of social presence is seen as less personal. Mental health can be defined as a growth towards optimal development, healthy psychological functioning, and resilience, thriving even in crisis. COVID-19 pandemic had devastating consequences not only for the healthcare and economy, but also, perhaps most importantly, to mental health. In Poland, half or more of people across all generations reported a negative impact on their mental health, although in younger generations there was also a small group of people whose mental health improved. The overall aim of this study was to explore the factors influencing our mental well-being during the lockdown. In particular, we explored these questions. What improved and what hindered high co-presence in personal and work-related communication during COVID? What was the role of co-presence in maintaining different aspects of mental well-being? How important were housing conditions, physical presence of others, or things like internet connection in maintenance of mental well-being? Our participants were mainly people between 20 and 40 years old who saw the invitation to the study on social media, mainly on Facebook groups. The average age of men and women was around 35, and we had many more women, although the distribution of age was very similar. Regarding the private situation of our participants, the majority lived with another adult. Among those who had children, dominated people who had one child, smaller or older. Most of our participants had the comfort of having a room for themselves. A few mentioned they had to share the room only from time to time, and so on. Most of the respondents moved to a house office setting, but could go out to do shopping anytime they needed and were not restricted. Only 15% could not leave the house at all at the moment of filling the questionnaire, so they were in strict quarantine, and a small group kept working as usual. Almost half respondents mentioned that their financial situation got worse. However, 4 participants claimed it actually improved. Now let's see the co-presence during calls. There were no gender differences and no differences in co-presence between private and work calls. But the factors that influenced the co-presence were different. So in private calls, co-presence was predicted by the time spent on video calls, although the effect was very small. It was also strongly negatively predicted by the total number of children. In work calls, the biggest effect had the time spent on video calls, but also the number of children and adults living in the same house had an effect, interestingly contrary. There was also a small effect of having a separate room and the number of hours spent on working, both improving the co-presence. In the next step, we analyzed the result of the adaptation of the Singapore Mental Wellbeing Scale. We chose it due to the fact that it captures also aspects related to social life, which was especially important in this study. We ran the principal components analysis, which yielded the distinct factor loadings. In our Polish version, we got 3 factors with eigenvalues above 1, which we called self-driven, relations-driven, and cognitively driven well-being. In the next step, we verified which factors, including the co-presence, had an impact on each type of mental well-being. We discovered that the higher co-presence in private calls improved both self-driven and relations-driven well-being. On the other hand, worsening financial situation had strong negative effect on self-driven well-being. None of these factors influence the cognitively driven well-being. Here, the biggest effect had the forced quarantine, probably related to the fear of the virus or having the virus. And there were small positive effects of hours spent on both private and professional calls. Among the conclusions, we can mention the following. First, that our study suggests that co-presence may depend on the context of communication. The quantity of video calls can help in every context. Perhaps it's a learning effect of habituation. Living with children makes it harder to be together with others in cyberspace. And in work calls, having private space and living with another adult helps to maintain well-being. The second question was the role of co-presence in mental well-being. We can say that it depends on mental well-being aspect we discuss. So for self-driven well-being, it can be threatened by worsening financial situation because it's a threat to self. A man makes his own destiny ideology, we can say. That's typical to Polish culture context right now. And it can be protected by being together in private calls. For relations-driven well-being, the most important is the quality of being together online. So not how much time we spend online, but how close we can feel when we are online. And for cognitively driven well-being, it can be threatened by the strict quarantine because you stay alone with your thoughts. And it can be protected by self-distraction, basically. So talking to others, working, anything that keeps us busy. The last question in the study was how important were housing conditions, physical presence, and internet, and so on. We concluded that living conditions may influence mental well-being indirectly. So co-presence can be clear, can have clear impact on mental well-being. Co-presence, especially for work calls, depends on the number of distractors, like cohabiting children, and the possibility of controlling them, so having a separate room. Co-presence seems more important than physical presence, but we can speculate that one can decide when and how long to be together in mediated communication, whereas living together during lockdown may be quite complicated and conflict triggering, let's say. Of course, the study had a pilot character, so the sample was not perfectly balanced and consisted of people who used Facebook, a computer, and so on. Therefore, the results cannot be generalized. But at the same time, we can say that the data is still valuable due to the unique time and circumstances. Further studies should explore whether these conclusions are correct. To summarize, I have a few takeaway messages. One would be that co-presence can be influenced by distinct factors depending on the context. Bad financial situation and strict quarantine can threaten mental well-being, but being together online may help protect it. What is important is that context matters. Thank you for your attention. Here you can find our contact data and some references relevant to the topic.
Thank you, Justina, for this wonderful talk. It was very interesting. Can you please say a few words about yourself now?
Hi, I'm a social psychologist working at the Institute of Psychology at Polish Academy of Sciences, together with Grzegorz, who was my PhD supervisor. I also work in a laboratory related to virtual reality in Barcelona. So I have double affiliation, and yeah, together with Grzegorz, we are interested in anything related to virtual reality, mainly. Grzegorz, want to say something too?
I have nothing to add, actually. You know me from the yesterday's session, and Justina said it all.
Okay, thank you very much for this introduction. It's time for the questions. If there are any questions, please do not hesitate to ask them in the chat. Come on, this was a very interesting study. Okay, if there are no questions, then I will ask mine, if you don't mind. The question is, well, I would say that you could expect some non-linearity in relationship between the quantity of video calls and the co-presence and the well-being, because when we have too many video calls, then we obviously get very tired, and it's I think it's very difficult to focus there. Did you look at this aspect of your data?
Not yet, but it's a very good point. So I'm sure I will go back to the data. But since the presentation was very short, I also didn't want to oversaturate it with results, I think. So, but it's definitely true that the number, the relationship may be nonlinear. I agree.
Okay, thank you very much. Since there are, I cannot see any more questions, I encourage everybody to join the chat room after the session and ask any questions that might pop up later on in the breakout room. Thank you once again for the presentation, and we will move on to the final one. The title of the final presentation is Technology Enables Struggling with Everyday Life's Course, Working Women with 2 or More Small Children are Confident Technology Users.
Good morning. Today I'd like to present the paper Technology Enables Struggling with Everyday Life's Course, Working Women with 2 or More Small Children are Confident Technology Users, done by Grzegorz Panerski, Gabriela Górska, which is me, Katarzyna Abramczuk, from the Laboratory of Interactive Technologies at National Information Processing Institute, and Piotr Toczyski from the Maria Grzegorzewska University. The study took part during the first weeks of the COVID-19 caused lockdown in Poland, which was also cause for a big change of working situation of many people. So they had to move from their offices to their house. To their houses, where some of them who had children had to probably participate in a different manner in their children's lives, also in their online education, as well as in the everyday course and everything within the same physical space, which is their house. We focused our attention on the situation of women, and the reasons are probably many, but we listed some of them on the right side of the presentation here. For example, a situation of stress that probably lockdown was for a lot of people, and we also have data for that. It may bring us back to our traditional norms, something that we know how works, something that feels safe. So Poland, as a moderately conservative country, has a pretty strong stereotype of what is house duty for women, which is also described here. A woman is responsible for the emotional development of their children, but also the emotional state of hold the house, women brings a feeling of love and care to their house. Also, a lot of household duties related to taking care of children is typically assigned to women. This was also noticed by the United Nations, who during the first part of 2020 had announced that the lockdown, the virus caused lockdown, could be potentially harmful to women professional careers. In our study, we decided to focus on women, especially on a very specific group of women with more than one child aged up to 12 years old. And there are a few reasons why to do so. In general, women tend to work at workplace and at home, but during the pandemic, they had to fulfill the same roles, different roles within one physical space. And this could be even more visible, the burden could be even more visible between the group that has more requiring children. But we also found a potential savior to this situation, which is technology. So we assumed in our study that technology could be a helpful tool that would support the professional fulfillment of overwhelmed women, but also not threaten their family life. The study took part in March and April 2020 during the first lockdown introduced by the Polish government. Our participants were aged between 25 to 65, and they work at least one day a week from home. We had 4 groups of comparison. The first one these were women with at least 2 children aged up to 12 years old. Then we compared them with a group of men with the same amount of children, then against women with only one child within the same age frames. And then the 4th group were men also with one child within the same age frames. And obviously, our main group of focus, these were the women with 2 or more children aged up to 12. All of the 4 groups had at least 2 adults within their household. We used several variables, but I'd like to shortly present you the pretty well-known one, Technology Adoption Propensity Scale, TAP. We used 3 subscales. So the first one is optimism. For example, new technologies make my life easier. Then we have proficiency. For example, I like finding out how new technologies work, or other people come to me for advice about new technologies. And then we also have vulnerability, and statements like, I must be careful while using technology, as criminals can make use of it to target me or to harm me. Or I believe high technology companies convince us we need things that we actually don't. And now I'd like to present you some of the results that we obtained. So we have here a group of women with more than one child, a group of women with only one child, men with more than one child, and men with only one child. And then we can compare them on, for example, the feeling of nervousness related to the pandemic, the perceived coronavirus risk, and the difficulties in focusing on work, and how often they help their children with lessons. As we can see, the reddest color denotes the highest score here. And the group of women with 2 children feel the most anxious, perceive the biggest coronavirus risk, have the most difficulties in focusing on work, and help their children with lessons more than other groups. Here we can compare if it comes to how many percent declared some of the statements, but here the difference between the anxiety is on a trend level between women with 2 children and women with only 1 child, and the perceived coronavirus risk here, it's a significant difference between those 2 groups. Now let's take a look at the results on the TAP scale. So here we can see the results on the subscale of proficiency, and there is a significant difference between the group of women with 2 or more children and women with only 1 child. Then, if it comes to optimism, once again, we can see the difference between women with 2 children and with only 1 child, but also between the first group and men with only 1 child. And the subscale of vulnerability showed no significant differences. We can conclude that women could be confident technology users, especially looking at the cultural norms, at the traditional gender roles, at the burden that is put on women. It seems that those who have more demanding situation also experience more stress and nervousness if it comes to the pandemic. They found their way out, possibly found their way out through technology and through digital optimism. What would be definitely interesting in this case for the future research would be incorporating the relationship status and seeing how the household duties are divided between partners in heterosexual couples. Also, what is the role of technology between them? Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you very much for this talk. I invite the authors to join me now. It's snowing, as you can see. It's snowing in Warsaw.
I thought that I will give excuses for Piotr Toczyski, but he probably used mobile technology, which helped him to say hello to us.
Yes, that's true. Nice to see you.
We have, I think everybody has introduced themselves already, right?
Exactly.
So we can skip this element now, and we will be happy to take your questions. Are there any questions? The last chance now. Well, not technically mistaken, not the last one. There will be also a chance to ask the questions in the breakout room after the session.
There is no question from you because you are co-author, so I think
I'm the co-author, so I'm not be asking any questions.
I think you know everything about the project, and I want to emphasize that this study was part of a larger project on forced remote working, and this is only a small piece of the whole picture, and Katarzyna is in charge of the project.
Okay. Since there are no questions, I just want to thank you, the authors. Thank you very much.
Thank you very much.
And I'll be closing this session. At the very end, I just wanted to apologize to Kamil for changing his gender. This was my not only intention. And I'll be closing the session. I know we are all looking forward to the keynote speech that will follow. And so I will pass the voice to Cesare now, I think.
Okay, thank you, Katarzyna. Thank you for chairing the session, and thank you for very interesting presentations. I think we had one presentation regarding voice assistants, which reminded me of one story. I'm using voice assistant at home, and I told my wife once that they are in fact spying on us, and she said nonsense and laughed. I also laughed. Also, Google Assistant laughed, and Alexa laughed. So back to more serious. This was by the way, I think last of the dead jokes I was giving you during the conference. And I must say it's quite hard to tell jokes on Zoom, as you don't see the reactions of the public. So if you like the jokes, just write in the chat. And also if you didn't like the jokes, then don't write on the chat. So. Next couple of jokes probably next year. So I invite you already. And now we have a couple of minutes to, after each of the sessions, join the breakout rooms for each presentation, and we also have a meditation room ready. So if you want to clear your mind before the keynote presentation, you can do so in our meditation room, and we'll be back in 10 minutes for the information about the Christophe Marasek Best Paper Award, and after that we'll be starting a keynote presentation by Professor Pedrich. See you in 10 minutes. Okay, and we're coming back for the Professor Christophe Marasek Best Paper Award for MIDI 2020. The first thing I'd like to mention is that the award was sponsored by one of the co-organizers of the conference, Polish-Japanese Academy of Information Technology. And first, as you see, we have two honorable mentions for a paper by Gulustan Dogan and team, a learning analytics case study, relation of students' learning approach to online learning environment behaviors. And the second honorable mention goes to Fatih Balki, Hilmi Demirhan, and Salih Sarp for the paper Neural Machine Translation for Turkish to English using Deep Learning. And the winner of this year Christophe Marasek Best Paper Award goes to Emil Kalbaliev and Samir Rustanov for the paper Text Similarity Detection using machine learning algorithms with character-based similarity measures. Congratulations to the authors, and I think we have authors with us. Would you like to say some words? I think Emil is here and Samir also are, so that's great. So the floor is yours if you'd like to say something.
Hello. Hello, everyone. It's such a great honor to receive Christophe Marasek Best Paper Award. I thank organizer of Machine Intelligence and Digital Interaction Conference for this award. I express deep gratitude to anonymous reviewers for the helpful comments and feedback. And I also want to thank Madam Safarov, Vasif Vahidov, and Ulvi Mehmetli for their assistance in this research work. I want to give word to the Samir Malim.
Yes, thank you all these conference organizers. Thank you for your reviewers, for our reviewers. Actually, from the reviewers, I felt actually this conference is a high-level conference because of two reviewers give very good, suggestion, recommendation, and they review very clearly, very accurately, I can say. It is describe your conference level. And as 2 days, I almost listened to all presentations. All of these works were selected very carefully, and all of them, they had very nice ideas and also scientific research, scientific achievement. I also congratulate all of our participants who participated in this conference. And I especially thankful to program organizer, reviewers, our conference attenders, and also especially my students that who helped us for data collections, and to our university management that to provide a very good opportunity to work, to do research in our data center, Center of Data Analytics and Research Center in our university. Thank you all. Thank you all of your support, I can say.
Thank you. Thank you very much. Thank you very much, and congratulations again. So this year the award goes to Hungary and Azerbaijan, the special prize of 500 euros for the best paper. So for details, please contact me directly after the conference. And now we are ready to move to keynote presentations, presentation that will close our conference. Presentation by Professor Witold Pedryk, who is a lecturer at University of Alberta, and also we have an honor to have him as a researcher at the National Information Processing Institute. He specializes in computational intelligence, fuzzy modeling, granular computing, data treatment, image recognition, and neural networks. And today, Professor Pedryk will talk about interpretability and explainability in data analytics, a design of concept with information granules. Professor, the floor is yours.
So I'd like to welcome everybody at the conference. I, first of all, would like to congratulate the organizers. I think it's just the 8th edition, and I think the topic is very timely, very important, and it's really an excellent opportunity to share some views, to share some research results, and to look at some future developments. So today I would like to talk about aspects of interpretability and explainability in data analytics. And in this context, I would like to sort of introduce ideas of concepts being realized by information granulars. So here's a brief outline of my talk. I would like to look first at some underlying ideas. So what is explainability, what is interpretability, and how information granularity comes into this entire picture. And then I would like to focus sort of in more detail on an idea of concept. So what is concept and how it is constructed? We'd like to bring to the discussion an idea of sort of combining domain knowledge and data through some specialized techniques of clustering. And then I would like to elaborate on more sort of detailed architecture that involve so-called logic networks, and look at some underlying interpretation and some design aspects. So what is explainability and interpretability? I think it's probably the best way is to start with some motivation. With the advent of artificial intelligence, which brought really a lot of interesting and far-reaching results with a number of theoretical and very much practical developments, comes a question of interpretation of the results and understanding the key ideas that are supported by AI constructs. And there are just a number of arguments that we can bring into the picture with this regard. First of all, we have this very important technical aspect. The constructs are complicated. In many cases, when we consider those quite visible techniques of deep learning, we end up having very multi-layered architectures with very limited insights into the functioning of these systems. And this raises some concerns, especially if we are looking at those constructs to support some decision processes that are realized in autonomous environment where you have a high level of criticality and substantial impact of these decision processes on a number of following sort of actions. Secondly, in just European Union, there is this question of right of explanation. So in other words, when you design the system, the AI system, you have to equip it with some mechanism offering an explanation behind the decision. So this is more these aspects of a sort of legal nature. And quite often, we can envision that there might be some malicious activities in the design. So when designing the system and using some data being sort of the key part of the design process, that some data could be sort of adversarial nature. So this essentially triggers a great deal of interest just to sort of endow the system with interpretability and explainability aspects. Those two concepts are, or those two ideas are related, however, they have a slightly different meaning, because when we are talking about interpretability, we are essentially looking at formation of results that are easily comprehended by the user. So in other words, we anticipate that the results are shown in the format and communicated in the way that we can easily understand those results, and we can take some actions based on what has been provided to us. So for instance, you can notice that, for instance, this type of statements are obviously meaningful to us as human observers, and they could trigger some action. Interestingly enough, it is worth noting that we are seeing these findings being delivered at a certain level of abstraction. So there is just a very important aspect, the way how we communicate and how we can envision that communication with the external world, with external bodies could happen, is that there has to be a certain level of abstraction. We are not necessarily are very much focused just on details. We would like to have some statements that are essentially comprehended, and also they are justified by the existing experimental evidence, by the data. And when it comes to explainability, we are really looking at the sort of ways of producing knowledge about relationship that have been sort of established, has been captured by models, so that these relations can be explained, can be sort of presented to the user in a response to the question, why have you arrived at a certain decision? What were the most essential essential features? What prediction could you get if there were some other particular factors taken into consideration. So in other words, in all these cases, we have some aspects of traceability of some reasoning or some inference process. And again, this is also very much linked to a certain level of abstraction, to a certain level of information granularity, as we can sort of put this sort of in a kind of brief way. Likewise, we have to admit that when we are talking about explainability and interpretability, this idea just, I think, surfaced about maybe 3 years ago. There was just an interesting project at DARPA where they sort of coined this term interpretable artificial intelligence, or XAI in brief. Again, we have to be very much aware of the fact that I think some of these aspects were very much present in the 70s, when in the era of AI, we had this period of expert systems, knowledge-based architectures, where when we talk about rule-based models, it becomes very much evident that these architectures have these explainability capabilities. So again, we can see a sort of deja vu that just is quite visible today, obviously in a slightly different and kind of extended technological framework, using different techniques in terms of sort of more advanced modeling sort of approaches. Now, when I've mentioned it several times that essentially we do not reason, or we do not process data themselves, but we, when it comes to some understanding of phenomena, we always sort of develop a certain level of abstraction that we think is the most relevant, is the most practical, is the most profitable in the context of a certain task. So for instance, having a collection of data, let's say you might have a sort of one sort of page of data, you just do a very quick scanning and you arrive at this sort of a very condensed, very concise, very abstract description of the data, such as being presented here. So I think those are the statements that are expressed in natural language. And obviously you can find a lot of similar examples. So for instance, looking at time series, obviously you can use sort of this sort of modeling techniques, but you can also, looking at this data, you can arrive at some statements that are qualitative to a significant extent, but they are also very much descriptive of the essence of the data. So in other words, we arrive at a concept that is central to the way how we perceive the world, how we look at the results, and that really is very much along the line of this idea of explainability and interpretability. Well, we are talking about the idea of information granulars and information granularity. It is so obvious, it is so straightforward that we do not pay sort of attention to this idea, but it is really present everywhere. So essentially, we are trying to bring a certain level of abstraction. We look at the results, we look at data from a certain perspective, so that we are really can see just a general idea. We can sort of look at the system from the most relevant perspective. So you can get just flexibility to cope with amount of details. We can come up with a concise description. We can sort of arrive at the same time at the stability of the description. So in other words, what is sort of more technical terms can refer to the idea of robustness. So if some small irrelevant changes in the data do not impact the obtained description. So that's what we can think of as a stability, something that I suppose we anticipate that any piece of knowledge should possess this ability. And on a more sort of technical side, we would like to see that essentially when we are looking at some constructs, they have to be based on some language of logic. So in other words, some expressions that you form to describe your findings have to be rooted in some logic architecture. And again, that's something that probably if you start connecting the dots, you can see that this is quite evident in rule-based architectures where we have rules and we have, for instance, decision trees where you can infer rules out of this architecture. And again, those are some sort of logic statements. So this brings us to this idea of concept. So in other words, if I'm looking at data or I'm trying to really look at some concept that is descriptors of this data that are really form the essence of the relationships and the essence of the sort of idea that is conveyed by this data. So essentially, we can view concept as some building blocks that essentially form this kind of blueprint, a skeleton of a modeling faculties. So again, I can sort of build a collection of concepts that are really a transformation of data into some pieces of knowledge. And again, as I've mentioned earlier, that this sort of design, so that concept have to be established at a certain level of abstraction that is the most suitable to the problem at hand and is the most relevant for the user. So it's kind of user-oriented activities that aim at data understanding. So this naturally brings us to a fundamental question. If I have a concept, is how could I arrive at its operational characteristic? So in other words, how are you going to construct this concept? And before we get to sort of more detailed developments, I think it is important to sort of underline that this engages kind of synergistic involvement of data and domain knowledge. So in other words, you have to really arrive at a certain kind of synergy that drives these developments. When we'll be looking at more sort of technicalities, then before that, it's probably worth stressing that the concept can be viewed from the sort of perspective of some symbolic view, okay? And the concept can be formalized and can be described in terms of some information granulars. So this is more sort of, abstract. This is sort of more non-technical sort of perspective. And this is just a way how you are going to arrive at a formalization of the concept in terms of information granulars and the way how this concept becomes designed. So there are just a number of these sort of key aspects that have to be considered, such as concept vis-a-vis existing experimental support. That is a question of some sort of requirements in terms of this coverage, that is how much data are really behind the concept and how this concept is specific. So, for instance, concepts can be viewed as some generic entities, such as, for instance, low productivity. So we have a concept, low productivity, and we want to essentially confront this concept and arrive at its operational description in the presence of data. Or another one, acceptable delay in supply chain. So here's a concept, and then I'm trying to describe this concept in sort of the present with the aid of my data. So in other words, this concept can be sort of built upon some variables, some attributes of the data, organized in a certain logical fashion. You may have just a sort of, in contrast to generic concept, you may have so-called composite concept, and as you can see, those are sort of composed of just some logic expression, like high error in position and low sort of and low changes of velocity. So we can envision that the concept is simply a certain piece of knowledge being provided by the user, who is going to arrive at the description of this concept in terms of experimental data being available. So in other words, we can envision that the concept is really just sitting on the top of this entire processing. Then we have data, and then this concept becomes described or it becomes positioned and described in this multivariable data space. I'd like to emphasize, that's what is being stated, shown here, that the concept is looking at all data, but the analysis and the description has to be implied by the concept. What I mean by that, that usually concept can sort of act as a certain filter over the entire data space but being sort of focused on what is relevant for this concept, okay? So how is this being done? Well, we are going to talk about this by referring to an idea that is very well known in data analytics, such as clustering, but here we would like to sort of make it more specialized by incorporating the concept in this construct. So that gives rise to so-called conditional clustering. I'd like to sort of contrast that when we are talking about clustering, and I think there's really a spectrum of possibilities here, then we are talking about capturing structure of data, not being essentially focused on a particular sort of domain knowledge that drives the entire process. Conditional clustering, on the other hand, is just offers you more focal activities within the bounds of clustering. So how does it look like? Well, I would like to concentrate as an example on one of the clustering technique. And this is really just for the sake of essentially focusing our discussion. And this is just an idea of conditional fuzzy clustering, conditional fuzzy C-means. Fuzzy C-means has been around for a long time. It has, just for those people working in machine learning, it has very kind of similarities, very significant similarities with K-means. And the idea is that having the data just composed of these elements in the data space and having just some variable over which we form our concept, we sort of realize clustering that is conditioned, and that's what I say, it's conditional. It's conditioned by the context, C, and this context is our concept. So in other words, we look at data and you try to find a structure in the data in length of a given concept. So again, we can see that there is not only the data that are involved, but there is also context or concept that is a driving force to run this clustering algorithm. So in other words, what we get at the very end of this entire process is just a partition matrix and the prototype. So this clustering technique is driven by a certain objective function that is optimized or it's minimized with regard to the structure that we have to find. So in other words, a partition matrix that is shown here and the prototypes shown here. So if you look at this formula, this nature of this objective function, we recognize that this is really nothing but a double sum which tries to minimize just a weighted distance of data from the prototypes. So the problem of determining the structure is really related to the problem of the certain optimization nature. So you minimize this objective function with regard to the partition matrix and the prototypes. So here's just the entire scenario. We have the data that are subject to clustering. We have the context that is our concept, and the concept is, as sort of indicated earlier, is really provided by the user. So this kind of more focused, more oriented sort of process of clustering. And here we minimize this sort of expression. And again, when you look at this problem, it's really a problem with sort of constraints. So essentially you minimize with the objective function with regard to partition matrix, and partition matrix satisfies these two fundamental requirements. This is the one that is obvious. So cluster has to be non-empty, but cannot sort of be the entire data space. But this is just a very important constraint because it tells us that essentially these degrees of sort of membership, so this is the elements of the partition matrix, they are constrained by the concept, okay? The entire scheme in terms of optimization is well known, is an iterative one. So this is just the main loop of iteration. And we iterate by adjusting partition matrix, and we adjust prototypes. I'd like to, again, emphasize that here is this guiding sort of component being provided by the concept. So in other words, what we can sort of envision is the process that we deliver some concept. So this is provided by the user. So it's kind of customizes the entire process. Then the concept just tries to focus our attention on some portion of data that are sort of relevant to the concept. And then these data are being clustered and we obtain prototypes that can be sort of shown here. And we also obtain the partition matrix. Prototypes in our context are sort of more important. Now, when we are talking about the concept, and again, I've mentioned the concept is just a certain symbolic entity. So in other words, you can, I gave you a couple of examples, and they are sort of concepts are described in those linguistic terms, in terms of some symbols. Now, if you are looking at the operational side, obviously we have to just to invoke clustering, but also to invoke a description of the concept in terms of data, the concept itself has to be formalized, and it could be conveniently done by viewing concept as an information granular in a certain space. So here we definitely have a large number of possibilities, because talking about information granulars, we are really seeing a number of possible ways of representing, of formalizing information granular. It could be an interval or set, it could be a fuzzy set, it could be a rough set, it could be intuitionistic fuzzy set, and so on. So I'm saying there is really a large number of possibilities. Again, which formulas you choose, it is really just a problem dependent. So essentially, when we get a concept being described by information granular, this is really just a formalization of this available domain knowledge. There is one point that has to be stressed here. That sort of was also highlighted before. Namely, concept has to be meaningful in terms of having some sufficient data support. So in other words, we require that essentially this data, the data that are behind the concept, they satisfy this requirement expressed in this way. So this is a sum of those, let's say, degrees of membership or characteristic functions over all data that fall within the bounds of the concept, that this sum, this total mass, is greater than some threshold. So in other words, we would like to sort of describe a concept that has enough sort of motivation, it has enough support in terms of existing data. Okay, so let's say that we completed this context-based clustering. So now we are at a position to essentially describe the concept in the language of this data. And I would like to have a description of the concept in such a way that it is just interpretable. So notice that once we completed the clustering process, we essentially got some linkage between the concept and the prototypes that are localized in this usually multi-dimensional data space. I'm showing you this two-dimensional situation to emphasize what the main problem is. Because anytime we have those prototypes in highly dimensional space, these prototypes are not necessarily easily comprehended, okay? So for instance, in a two-dimensional case, what are the prototypes? Well, they are just being shown here. And what do they mean? Well, it's not so sort of obvious what their meaning is, especially if you go from a two-dimensional space to highly dimensional space. But we can facilitate, we can sort of augment interpretation if we take these prototypes and do the projection on the individual coordinates. Because once you got the projection, then rather than talking about the numeric values of these projected prototypes, you can associate with them some labels or some symbols, well, which I think is quite straightforward because there's a linear order along each coordinate. So we can talk about just this projection associated with the concept or with the symbol small, medium, large, and so on. And likewise, you can talk about this as sort of a second coordinate. And again, looking at a projection, we can sort of do the same labeling. So you have symbols. So this translates the numeric representation, the numeric manifestation of the prototype into, in this case, a pair of symbols. So again, this is just more readable, easily comprehended by the user. So in other words, concept is described by this pair of labels, or this pair of label, or this pair of labels. So, so in other words, we really arrive at the kind of symbolic view of the concept that is being provided in light of the sort of data being sort of analyzed. Now, I would like to get a little bit more sort of comprehensive picture, because sorry, I have the concept and I have these sort of prototypes described at the symbolic level. So how could I connect them into a single architecture? And here, where this idea of logic network comes into play. So essentially, I can form a network that has two layers. And the first layer, what we do, we essentially just looking what has been sort of presented here. We are forming an aggregation, being more specific, and combination and aggregation of these individual symbols. So as you can look at the prototype V1, then it is composed of large and medium defined or formulated over X1 and X2. Likewise, if you look at the second one, there is a small and large. So you can see there's a small and large sort of that gives rise to this logic aggregation. And likewise for the last prototype. Obviously, if you have more prototypes, then this layer is going to be broader. And then essentially we sort of, again, look at the description of the concept. So we say the concept is either this one or this one, or the third one. So essentially, then you put them together in a single sort of node that has this sort of a flavor of this or combination. So if you are sort of seeing this on a kind of overall picture, this is just an architecture. So essentially what we did, we created a logic network that now allows us to describe, to articulate concept in terms of the symbols formed in the individual variables of the entire data space. So this is just the skeleton, because essentially one could think about augmenting this logic network by some learning capabilities. So in order to do that, we have to essentially make sure that the network has some parametric flexibility. And this is being done by implementing this sort of processing units by some connections. But so everybody would say, okay, this resembles a neural network, two-level neural network. Yes, but to some extent, because here each processing unit has some underlying logic processing. So here we can view those as so-called AND neurons or AND processing units that are described by these expressions. So X are sort of the inputs and W is a vector of the weights that you can sort of optimize. You can adjust them to carry out optimization of the logic network. This is known as end neuron, and I think this aggregation being realized here is carried out by the so-called min-max composition. Here, this is an OR neuron, so essentially you can see that this processing is again realized by min and max, but those operators are placed in the sort of reverse order as in contrast to is presented here. In general, instead of min and max, you can use some logic connectors such as those known in fuzzy sets as T-norms and T-conorms. So now, given the fact that essentially we have data, so in other words, we have some for each data point, we have a manifestation of the concept, but we also have this data that can invoke this individual sort of elements, information granulars in this input space, then you can sort of make adjustments to the weights of these neurons so that you minimize the error between the experimental findings, so with the formulation of the concept and the sort of result being produced by this description. And this could be done, for instance, by invoking a gradient-based learning, but obviously there could be an entire sort of slew of possibilities here in terms of optimization. So what we really did is the following. We said we are interested in a certain concept, and then by confronting this concept with the data, we came up with the sort of description of this concept expressed in terms of the symbols formed in the individual variables, individual attributes present in the data. So essentially we got the concept that is characterized by this type of logic network. But we have to admit that there could be more than a single concept. So then we form just a collection of these networks. So you can notice that essentially because our data can be regarded as a union, as a sort of description being realized by the collection of concept, so then we can think about some sort of OR combination of the concept. So then you have another sort of layer in this overall structure that serves as an OR neuron. Now, one could sort of emphasize that when we build concept, the concepts have been constructed individually. So in other words, I have concept one, I run conditional fuzzy clustering, and then I get just sort of the prototypes. And then obviously I can form this entire structure. So notice that the prototypes that are formed here are not necessarily the same as prototypes here, because then you invoke some other concept and you repeated the entire process from scratch. So saying you did context-based clustering of the same data and you obtained sort of resulting relationships. So again, that's what I mentioned here, that this term in sense of symbolic nature are the same, but it does not mean that they are the same at the numeric level. So the prototypes do not coincide when you are sort of forming just individual concepts. So what this means that essentially, if you want to get some kind of common ground, that means that you would like to develop some prototypes that are common from the sort of perspective of all these context-based clustering. So that means that if you were forming one concept, you obtain prototypes that are provided here. So you consider that here you might have different number of clusters than when forming another concept, and so on. So altogether, you can have just prototypes, and then they are different. So in other words, if I want to get kind of unified view, so trying to describe all concepts, having the same symbolic representation. So in other words, this is symbol L, and this is also symbol L and symbol L, and they have the same underlying content, then essentially I have to really do something that can be regarded as a double level clustering. Well, I'm talking about double level clustering because clustering, what we did before was really focused on clustering data. But here we are not clustering data, but we are clustering prototypes that have been established by different contexts. So in other words, you cluster prototypes. So that's why we may refer to this as a process as a double level clustering. So then when you do clustering of these prototypes, you obtain the results that are sort of prototypes out of forming sort of describing this data. This is VI tilde. And then you can essentially, obviously, when you have these prototypes, you can sort of come up with their symbolic representation, but then also you can sort of using this kind of nearest neighbor rule, you can essentially, instead of talking about these prototypes, you can express them in terms of this results produced by the second clustering phase. So this really just gives you this kind of unified view. Okay, this sounds like a good descriptor, operational descriptor of the concept, but it's not interpretable in the case where you have highly dimensional space of data. Because the formula, like what I presented in terms of making projections, well, it makes sense, but you are facing a certain difficulty just at this point. Because while you can sort of easily interpret this sort of symbolic description of the prototypes, what if you have a large number of variables? Well, this is going to produce a long list of symbols, and that's not necessarily I can get a good sort of picture of this sort of behavior, the nature of the prototypes, okay? So what could be done? Well, you can go to a certain level of abstraction by essentially converting this expression, that is the symbolic description of the prototype, to a so-called linguistic approximation of this expression. So essentially what we are doing, we are introducing a concept of linguistic quantifier, and then the statement of this nature can be described. So in essence, the concept can be described in a more compact way by invoking or by generating a statement that most variables assume low values, okay? So essentially it's just an idea of linguistic approximation being proposed by Jaeger and Katschek just some time ago. And this becomes quite instrumental in this sort of description, concise description of the concept. This statement is far more descriptive, it's far more easily comprehended in terms of the sort of its understanding. Now, how is this entire process realized? How we're going to move from this expression, logic expression, to this logic expression? Notice that in the construct here, we are talking about so-called linguistic quantifier that can be, for instance, represented as sort of this type of term. So in sense of some membership function of fuzzy sets, they could be conveniently described by some fuzzy sets reflecting the semantics. So if you say at least, let's say about 60%, then it could be just this fancy set. If you say most, then it could be a kind of monotonically increasing function of its argument. So essentially the idea is to determine the linguistic quantifier and to determine just the most relevant linguistic label that is described, that describes this sort of more detailed expression. So notice that, again, linguistic approximation gives you this idea of a more comprehensive, more condensed view at the description of the concept. And how this process of transformation is realized? Well, it is, that's what is kind of states in this, this idea, it's linguistic approximation. So if you have a certain finite number of linguistic terms, symbols, and if you have a finite number of linguistic quantifiers as being presented here, then essentially we have to find the best element from this collection of symbols and from the collection of linguistic modifiers, such that distance being the distance between the original description and this sort of linguistic, this compressed description is as small as possible. So in other words, notice that by doing this, we essentially are taking this description of the concept that is quite long to the description of the concept that reads like this. So essentially we are bringing the same sort of a single symbol to the inputs of this particular processing unit. And this is just a transformation from this description of the concept, from this characterization is realized through this linguistic approximation. Okay, I think I try to just demonstrate and try to advocate that the idea of interpretability and explainability, the ideas, they come inherently with the idea of information granules. And again, looking at this sort of such ideas as concept, we showed that essentially concept can facilitate this entire development along the line of interpretability, and the concept can be also constructed in an efficient way by invoking some joint mechanism of data processing and knowledge-based processing. So essentially bringing data and bringing domain knowledge under the same sort of banner to realize a symbolic description of data. Obviously, there are really a number of possible directions one can take in sort of developments or enhancements of ideas of interpretability. As I've mentioned earlier, rule-based models have been around for a long time. So essentially we can look at linkages between the rule-based models and rules and concepts and see how rules can be described in a sort of efficient way through a collection of concepts. With this, I would like to thank you very much for your attention, and I will be happy to take any questions, any comments you might have. Thank you very much.
Okay, thank you, Professor, for a very interesting presentation. Do we have any questions in the chat?
Yeah, I'm opening the chat.
Yeah, if you could look at the chat directly. That.
For the time being, I don't have any, but obviously, if you have some questions that would come maybe a bit later, please do not hesitate to contact me. I'll be happy to answer questions, but obviously I'll be happy to provide more material and sort of more detailed information that relates to this talk. Okay, thank you very much.
Thank you very much for being with us. Okay, this brings us to the end of our conference this year. I would like to thank all the co-chairs of the conference, Professor Sikorski, Professor Kacprzak, Dr. Owsiński, and Dr. Romanowski, all the institutions that were co-organizers of our conference, that is National Information Processing Institute, Łódź University of Technology, Polish-Japanese Academy of Information Technology, and System Research Institute. Also, I would like to thank all the team from the Laboratory of Interactive Technologies here at NIPI who are involved in preparing the conference. I think that really it went smoothly. Also, I would like to say thanks to all the other people at NIPI involved in other departments that helped to make this conference reality. So thank you again for participation. Thanks for the also thanks for the chairs of the session for making that everything went very smoothly. If you would like to contact me regarding the conference or any other issues, please feel free to email me. You have emails shown currently on the screen. Also, I would like to mention that we work very hard in order to make the proceedings of the conference available as soon as possible. As soon as I know details, I will be sending emails to the authors of the papers presented here. But we have some delays caused partly by the pandemic. So please forgive me if it takes a bit more time than it usually takes for the proceedings to appear. But we are working on it, and they will be available. Also, okay. So I think that would be it. So please join us for the MIDI next year. I think that next year this conference, and I hope that next year this conference will be even better. Thank you again for participation, and I hope to see you next year. Bye.